The experiment that broke time. Sometimes, the strangest discoveries come not from trying to find something new, but from simply watching something closely enough to notice it behaving in a way it shouldn't. That's exactly what happened when scientists ran an experiment. They thought they understood, only to realize that time itself wasn't playing by the rules. And what they saw quietly shifted our understanding of cause and effect. They were working with particles. Subatomic, incredibly small, impossible to see particles like photons and electrons. And they were testing something known as quantum entanglement. That's when two particles become connected, even across long distances. Whatever happens to one seems to instantly affect the other, no matter how far apart they are. Which is already strange, because it suggests that information can somehow travel faster than the speed of light. But that wasn't even the part that broke time. The real twist came with something called the delayed choice quantum eraser. It sounds complex, but the idea is simple once you let it settle in. Imagine a particle that has to choose between two paths. You send it toward a screen, and if you don't observe which path it takes, it acts like it traveled both paths at once, like a wave spreading out and interfering with itself. But if you do measure which path it took, suddenly it behaves like it only went one way, like a single dot instead of a wave pattern. Just the act of observing changes what it does. So far, that's classic quantum behavior. Weird, but expected. But in the delayed, choice version of this experiment, scientists let the particle hit the screen first, and only afterward decided whether or not to measure which path it had taken. In other words, they made the choice after the event had already happened. And somehow, impossibly, the particle's past behavior changed based on what they did in the future. The decision made later seemed to reach backward in time and rewrite what had already occurred. That's not science fiction. That's a real result from real experiments. It has been repeated, confirmed, and accepted in mainstream physics. The particle acted like it knew what the scientists were going to decide, even though that decision came after the fact. The cause followed the effect. Or maybe the effect led to the cause. It's hard to say, because in this case, the line between them got blurry, and this isn't some fringe corner of science. This is part of quantum mechanics, the same system that powers our computers, GPS, lasers, and nearly everything modern. It's as real as gravity, even if it makes less sense. Now, to be clear, this doesn't mean you can send a message back in time. It doesn't mean you can rewrite your childhood. But it does mean that time, especially on the smallest scales, doesn't behave in a straight, forward line. It behaves more like a web, or a loop, or something else entirely that we don't have language for yet. The arrow of time that we experience, that steady sense of past leading to present, and then future, may not be a fundamental part of reality. It might just be a result of how we perceive the world. The brain loves order. It needs a timeline, so it builds one. But that timeline might not exist out there in the universe the way we assume it does. This has huge implications, not just for physics, but for the way we think about memory, choice, and even free will. If actions in the future can somehow influence outcomes in the past, even at the tiniest level, then what else are we misunderstanding about how events unfold? And maybe that's the point. Maybe the deeper we look into reality, the more we find that the universe doesn't operate the way our brains expect. Not in straight lines, not in strict order, but in something more fluid, more subtle, something that unfolds both forward and backward, depending on how you look at it. You might never feel it in your daily life. To us, time still moves in one direction. We wake up, we go to sleep, we remember yesterday but not tomorrow. But deep underneath all that in the quantum world, time might be more like a suggestion than a rule. And if that's true, then everything we've built around the idea of before and after, of cause and effect, might only be part of the story. This experiment didn't give us all the answers, but it did open a door. A quiet, mysterious door that hints at a universe more flexible and more connected than we ever imagined. And behind that door, time might not be broken. It might just be more alive than we thought. The signal from space no one can explain. In August of 1977, something happened that still has scientists scratching their heads nearly 50 years later. A brief moment, only 72 seconds long, that came and went without warning. A transmission from space that no one has been able to explain. Not then, not now. It came through a radio telescope in Ohio, part of a project called the Search for Extraterrestrial Intelligence. They were scanning the skies for patterns, listening for anything unusual, and night after night, it was mostly silence. Static, predictable noise. Until one day, it wasn't. A sudden spike, a sharp, clear signal, strong, focused, and completely unexpected. It appeared on a frequency around 1400 megahertz. That detail might not sound important, but it is. That frequency is tied to hydrogen, the most abundant element in the universe. Scientists consider it a kind of universal calling card. If intelligent life ever wanted to get a message across, that is the frequency they would most likely use. And this signal was not just powerful. It was precise. No drifting, no spread. It came in like a clean line. It did not look like a star. It did not look like a galaxy. It did not look like anything Earth-based either. And then just as suddenly as it arrived, it vanished. Gone. A volunteer named Jerry Emin was the one who spotted it on the printed data sheet. The intensity of the numbers jumped out immediately. He circled the reading and wrote just one word in red pen next to it. Wow. That is what it came to be called. The wow signal. And in all the years since, nothing like it has ever been recorded again. Astronomers have pointed telescopes at the same region of space many times. They have listened with better equipment, waited longer, searched wider. But the sky has stayed quiet. Whatever caused that signal has never returned. And that makes the mystery even harder to solve. There were theories. Maybe it was a satellite. But the telescope was designed to ignore signals from Earth. It also used two separate detectors, and only one of them picked up the transmission, which matches what you would expect from an object in space moving through a narrow beam. That actually makes it less likely that it was something local. Others suggested it might have been a comet. Comets can emit radio waves under certain conditions, but they do not send narrow-band signals that look like artificial communication, and nothing about the timing or the intensity made sense for that theory either. So we are left with a strange kind of silence. A single moment of something that clearly stood out, followed by decades of nothing. And that raises the question, what if it was not random? What if it was deliberate? There is a possibility, however small, that someone or something out there sent a signal in our direction. Not to say hello, not to start a conversation, but just to see who might be listening. And we happen to be listening. It was short, it was simple. It never came back, but that does not mean it was meaningless, because the universe is vast, beyond counting. Stars and planets scattered across billions of light years, most of them silent, most of them empty. But not all of them, not forever. And if one of those distant worlds decided to reach out across the void, to send even the smallest whisper toward our little corner of space, it might sound exactly like what we heard. A flash of signal, one clear tone, 72 seconds of something that should not be there. And maybe it was not meant for us. Maybe it was not even meant to be received. Maybe it was just a byproduct of something larger. A technology we do not understand. A conversation we cannot interpret. A footprint left behind by something passing through. Or maybe it was meant for us. And we missed the rest of the message. That is the haunting part. Not just the signal itself, but the silence that followed. The thought that something extraordinary happened, and we did not know what to do with it. We could not decode it. We could not answer it. We could only mark it with a word on a page and keep waiting. And yet, that moment still matters. Because even without a repeat, even without confirmation, it reminds us that we are not just observers. We are participants in a universe that is still full of unknowns. And sometimes, the unknown knocks once, then disappears. But maybe once is enough. The WOW signal remains one of the strongest candidates for an intelligent transmission from beyond Earth. Not because it proved anything, but because it refused to be explained away. It was clean. It was precise. It broke the pattern of noise and randomness. And it left a trace that continues to challenge everything we thought we knew about what is out there. There are no answers yet, and there may never be. But in that 72-second window, something happened. Something real. Something that continues to echo, not in space, but in the questions it left behind. And maybe that is what keeps us looking up. The particle that knows you're watching. There's a particle that behaves one way when you are not looking at it, and a completely different way when you are. Not once. Not occasionally, but every single time. This is not a metaphor. This is not science fiction. This is a real phenomenon, backed by repeatable experiments and confirmed results. The particle changes its behavior based on whether or not it is being observed. And no one fully understands why. It is called the double-slit experiment, one of the most famous and unsettling demonstrations in quantum physics. If you have never heard of it, it sounds almost too strange to be real. But if you take a deep breath and let it play out in your mind, it will change how you think about reality. Start simple. Imagine a wall with two narrow slits cut into it. Now imagine a machine that fires tiny particles at that wall. Electrons, photons, something small enough to act as both a particle and a wave. Behind the wall is a second screen that shows where each particle lands. If you cover one slit and fire the particles, you get a pattern directly behind the open slit. Nothing surprising. If you open both slits, though, something strange happens. Instead of two patterns, like you would expect, the particles form an interference pattern. Like ripples in a pond crossing over each other, that is what waves do. Not particles. But here, each individual particle seems to go through both slits at once, interfere with itself, and land somewhere in the pattern as if it took every path at the same time. So far, still strange, but it gets weirder. Scientists thought, let's see what is actually happening at the slits. Let's put a detector there to measure which slit the particle goes through. That way, we can catch it in the act. But the moment they tried to observe the particle's path, the interference pattern disappeared. Just like that. Gone. The particles stopped behaving like waves and started acting like little solid bullets again. Each one chose a slit. Each one followed a path. The result changed completely. Nothing else changed. Same particles, same slits, same setup. The only difference was that someone tried to watch, and this has been repeated many times with different particles, with different detectors. The outcome is always the same. When you observe the path, the wave collapses. The particle behaves differently, as if it knows, as if your act of watching changes what it does. Now, it is important to say the particle does not have a brain. It is not aware in the way we are aware. But somehow, the simple fact of measurement collapses its range of possibilities into a single outcome. Before you looked, it was doing everything at once. After you looked, it had to make a choice. This is called wave function collapse. In quantum physics, a particle exists in a superposition of all possible states until it is observed. Then it picks one. That alone is strange enough. But what does it mean to observe something? Is it the detector? Is it the human mind? Is it consciousness? That is where things start to get blurry. Some interpretations of quantum mechanics say it is the act of measurement that causes the collapse. Nothing mystical, just physics. But others suggest that awareness itself may play a role. That consciousness might be more connected to the fabric of reality than we realize. And while that is still a matter of debate, it has not been ruled out, because no one has been able to fully explain why observation matters so much. Imagine living in a world where everything you see only behaves a certain way because you are seeing it, and when you stop looking, it goes back to existing in multiple possibilities. You do not notice it because on the large scale, things average out. A baseball, a car, a tree. They are made of particles too, but they contain trillions of them, all acting together. So the strange quantum effects get washed out. But at the smallest levels, they are still there, still shifting, still uncertain, until someone checks. That means reality itself is not as solid as it feels. It is more like a probability cloud that settles into place when attention is focused on it. And this is not philosophical guessing. This is hard data. Every time someone runs the experiment, the results say the same thing. What we expect to be fixed and stable turns out to be reactive and dynamic, and the act of looking is never neutral. It shapes what is there. So where does that leave us? It leaves us with a world that is far stranger than we were taught. A world where information and observation might be fundamental. Where cause and effect are not always clear, and where what we see might not be all there is. It makes you wonder how many other things in life behave differently simply because we are paying attention to them. Not just in physics. In everything. People change when they know they are being watched. Animals behave differently in captivity than in the wild. Even your own thoughts shift when you speak them out loud. Maybe that is just psychology, or maybe the border between the mental and the physical is not as clear as we think. The particle does not know you in any personal way, but something about the interaction between observer and observed cuts deeper than anyone expected. And the deeper we look, the more we find that nothing stays the same when you shine a light on it. Reality is not waiting for us to discover it. It is responding to the fact that we are here. The human who lived with half a brain. There is a woman walking around today with half a brain. Literally. One entire hemisphere of her brain is gone, removed, surgically taken out, and yet she is fully conscious. She talks, she walks, she understands humor, she feels joy, sadness, memory. She is aware of herself, she is aware of you. This is not science fiction. This is not a figure of speech. This is medical fact. and it has forced neuroscientists to rethink some of the most basic assumptions about how the brain works, about what consciousness really is, and how little we truly know about where the mind lives. Her name is not always shared publicly to protect her privacy, but what happened to her has been documented, studied, and confirmed. She was born with a severe neurological condition, one that caused uncontrollable seizures, hundreds of them every week. Medication did nothing. Traditional surgery did nothing. So the doctors made a decision that seemed unthinkable. They would remove half of her brain, not a piece, not a section, an entire hemisphere, either the left or the right, depending on which side was responsible for the seizures. They call it a hemispherectomy. It is rare, but it has been done. And the results are hard to believe. You would think removing half of the brain would destroy a person, take away their language, their memory, their ability to move, their sense of self. But it does not. In many cases, the person continues to live a completely functional life. They are slower in some areas. They struggle with some things. But overall, they are still fully aware, fully human, fully themselves. How is that even possible? The brain is not like a hard drive. It is not divided into folders and files where one side does logic and the other side does emotion. That is a myth. In reality, the brain is more like a living network, a web of connections that adapts constantly. It can rewire itself, redirect functions, move tasks to different areas when damage occurs. And when someone is young, that flexibility is even stronger. The younger the brain, the more it can reorganize itself. So when doctors remove an entire hemisphere in a child, the remaining half often picks up the slack. It starts to handle language, motor control, even emotions and social behavior, all the things we assumed were locked into fixed regions. This woman, who had half her brain removed as a child, grew up. She finished school. She reads. She speaks. She laughs. She has opinions. She remembers her past. And she is fully aware of what she lost and what she did not. Even imaging scans show how the remaining hemisphere stretches and expands its functions. The brain does not just give up. It fights to adapt. It fights to remain whole, even when half of it is missing. That alone is incredible. But it gets even deeper. Because consciousness, that sense of being awake, aware, present, is not supposed to be something that can survive major structural damage. And yet here she is, with one side of her brain missing, and still very much alive inside. This raises a disturbing and beautiful question. Where exactly is the self located? If a person can lose half of their brain and still be fully themselves, then consciousness might not live in a single spot. It might not even be a thing. It might be an experience, a pattern, a process that can emerge from almost anywhere, as long as there is enough structure left to hold it. Maybe it is not about what the brain has, but what it does. Maybe the self is more like a song than a statue. Not a solid object, but a moving shape, one that can shift from one instrument to another. As long as the melody continues, the music goes on. Think about that. Half of your brain could disappear, and your sense of being you might still remain. That changes everything we think we know about identity, about memory, about death, and it proves something else too. The brain is not fragile. It is not helpless. It is one of the most resilient systems in the known universe. It is not made to be perfect. It is made to survive, to reroute, to adapt, even when half of it is gone. And it does not just survive. It finds ways to thrive. That is what stuns doctors the most. Not just that these patients live, but that they go on to feel meaning, to experience connection, to hold conversations, to dream, to imagine, to reflect on their lives with the same richness and depth as anyone else. Of course, there are challenges: weakness on one side of the body, delays in certain areas, difficulty with spatial tasks or abstract reasoning, but those are just details. What matters is that the core remains, the spark, the perspective, the inner world. And if that can remain with half a brain, then what we call the mind is far more flexible than we ever imagined. Maybe your memories are not stored in a single place. Maybe your personality is not tied to a certain fold or lobe. Maybe consciousness is not trapped inside a box. Maybe it flows, fills the space it has, expands to the shape of what remains. This woman, and others like her, are living proof that the mind is not a machine. It is something else, something more fluid, more mysterious, more powerful. Half her brain is gone, and yet she is still here, fully present, fully real, and completely alive. The lights that appear in the sky for no reason. In certain places around the world, people have been witnessing strange lights appearing in the night sky. Not once or twice, but over and over again for years. No one knows where they come from, and more importantly, no one knows why they show up. They are not meteors. They are not planes. They are not satellites. And the more people study them, the more confusing they become. One of the most famous spots where this keeps happening is a small valley in central Norway called Hessdalen. Since the early 1980s, bright glowing orbs have been reported floating through the sky there. At first, locals thought it might be aircraft or maybe some kind of rare weather, but it kept happening. Sometimes the lights appear as glowing white spheres. Other times they come in pairs or groups. They can hover in place for several seconds, then move horizontally at a speed no known object can match, and then just vanish. No sound, no smoke, no warning. What made Hessdalen different from other sightings is that scientists actually got involved. Not just believers or hobbyists, but real researchers. Universities set up equipment in the valley, cameras, radar, instruments to track electromagnetic activity, and the lights kept showing up. They were captured on film, tracked on radar, recorded across multiple types of sensors. These are not tricks of the eye. They are real and measurable, but no one can say what they are. They do not act like anything else we know. They are too slow to be meteors, too silent to be helicopters or drones, too low to be satellites, and too stable to be explained as lightning or electrical discharge. A few theories suggest they could be some kind of plasma, natural energy created by underground minerals or tectonic friction, and maybe in some cases that explains it. But plasma does not respond to people. It does not move in coordinated ways. And it definitely does not behave like it is aware of its surroundings. Some people in Hessdalen said when they tried to flash lights at the orbs, the lights would respond by pulsing back. Others said the lights would change direction suddenly, almost like they were avoiding obstacles or reacting to being watched. That is where the scientific explanations start to fall apart. Because we are not just talking about glowing blobs, we are talking about lights that seem to move with purpose. It is not just in Norway either. Similar lights have been seen in places like Marfa, Texas, Brown Mountain, North Carolina, Yakima, Washington, even parts of Australia. Same story every time. Lights that appear out of nowhere, bright, silent, sometimes colorful, hovering, flickering, moving in ways that do not follow any known flight pattern, and always leaving more questions than answers. Over the years, people have tried every explanation they can think of. Atmospheric gases, ball lightning, static discharge, secret military tech. Some of those theories work on paper, but they never explain all the behavior. How do you account for lights that appear during clear skies with no storms nearby? How do you explain lights that suddenly shoot upward into space or split into two and then rejoin? Even trained pilots and researchers have admitted they cannot explain what they are seeing. Not everything unexplained has to be aliens, but that does not make it less real. These lights are being documented, measured, filmed. This is not about blurry photos or conspiracy. It is about an ongoing physical event that we still do not understand. The most frustrating part is how consistent it is. People have been reporting the same kinds of lights for decades across cultures and continents. They appear near mountains, valleys, deserts, sometimes over the ocean, always in remote areas far from major cities. And yet they show the same patterns, same size, same glow, same strange movement. There has to be something causing it. But every time someone tries to pin it down, it slips through. This has led to a deeper question that makes people uncomfortable. What if there are things in our environment that we simply have not discovered yet? Not creatures, not spaceships, just natural phenomena that do not fit into our current models. Light behaving in strange ways, energy forming patterns we do not expect. Or maybe there is something we do not even have language for yet. The truth is, there are still gaps in how we understand the world. We like to think everything has been mapped, that we know the sky, the weather, the atmosphere. But these lights are a reminder that nature might still have surprises. And maybe they are not waiting to be discovered. Maybe they are just doing what they have always done. We are just now noticing. It is easy to dismiss strange things when you cannot explain them. But the more you look into these lights, the harder they are to ignore. And the more you realize that we might not be as close to the full picture as we think we are. Because whatever these lights are, they keep showing up, and they are not asking for attention. They are just there, quiet, bright, moving with no sound, no warning, no clear reason at all. The place in the universe that shouldn't exist. When astronomers first mapped out the cosmic microwave background, they expected to see tiny variations in temperature. That part was normal. The early universe was never supposed to be perfectly uniform. Some spots came out a little hotter, others a little colder. All of that was expected. What they did not expect was a giant cold hole in space. A spot so empty and so strange, it looked like something was missing. Not just a colder region. A region with almost nothing in it at all. They call it the supervoid. It is located in the direction of the constellation Eridanus, and it is huge. Over 1 billion light-years across. Not million, billion. That makes it one of the largest structures, or rather, non-structures, ever observed. Here is the part that makes scientists uncomfortable. There should be galaxies in that region. Not just one or two, but thousands. Space is supposed to be filled with galaxies. No matter where you look, even the empty spots usually have something. But this cold void barely has anything. It is not just dark. It is almost silent. This goes against what we thought we knew about how the universe formed. The large-scale structure of the universe looks a bit like a cosmic web. Galaxies form along filaments, like beads along strands, with voids in between. But even the voids are not truly empty. They are just thinner. You are supposed to see some matter in there. Some faint light. Some hint of structure. The Eridanus supervoid breaks that pattern. It is too empty, too cold, too big. And when researchers try to simulate how such a thing could form naturally, The math just does not support it. It is not just unlikely. It is nearly impossible. So now the question becomes, what could have caused this? Some think maybe there is a cluster of dark energy or dark matter that repels regular matter, pushing it away and leaving a void behind. But that is just a guess. No one has found direct evidence of anything like that in this region. Others have suggested that what we are seeing might be the result of something even weirder. Some kind of interaction between universes. That maybe, just maybe, this cold spot is a scar, a place where our universe bumped into another one early in its formation, a glitch left over from the birth of the cosmos itself. Now, to be clear, that is not a mainstream idea, but the fact that people are even considering it shows how confusing this discovery really is. The supervoid was first detected by looking at temperature anomalies in the cosmic microwave background. That is basically the afterglow of the Big Bang, a faint radiation that fills the universe. It is everywhere, and usually it is pretty uniform. But when researchers zoomed in on this one patch, they noticed it was significantly colder than the surrounding space. At first, they thought it might be an error, a calibration issue. Maybe the satellite picked up some interference. But then more instruments confirmed it. More data kept pointing to the same place. It was not an illusion. It was real. Later, when astronomers used surveys to look for galaxies in that direction, they found hardly any. That sealed it. This was not just a cold patch. It was a cold patch with almost nothing in it. Not just colder radiation, but missing mass. A giant region of space where matter just never seemed to form. And the more we study it, the more mysterious it becomes. Some researchers think it might be a coincidence. A combination of multiple small voids overlapping just right to create a larger one. But again, the odds of that are incredibly low. It would be like flipping a coin 1,000 times and getting heads every single time. Possible on paper, but not something you should ever expect to see in real life. So we are left with a place that challenges the structure of the universe. A place that feels like a cosmic accident. Like a hole in the story. And what is even more strange is that it does not seem to affect us. It is not dangerous. It is not pulling anything in or sending anything out. It is just sitting there. Quiet. Still. Inexplicable. Sometimes the most unsettling discoveries are not the loud ones. They are the silent ones. The ones that just sit there, not making sense. Not breaking the rules in obvious ways, just quietly reminding you that something is missing. Something does not add up. The Eridanus supervoid is not just empty. It is unexplainably empty. It is too big and too cold and too quiet. And the universe is not supposed to have places like that. But it does. And we still have no idea why. The brain that made a choice before you did. There is something we all believe without ever really saying it out loud. That when we make a decision, any decision, we are the one doing it. That it starts inside of us. That we are in charge. You decide what to eat, where to go, who to trust, and it feels like it happens in real time. You consider your options, weigh the pros and cons, then choose. Simple. But that's not how the brain works. Not even close. There was this experiment that quietly shattered the whole idea of conscious choice. It was one of those studies that seems boring on the surface, until you hear what it really found. Scientists placed people in front of a screen, told them they could press a button whenever they wanted, left hand or right hand. Didn't matter. Just make the decision, then press. What they were really measuring was the timing. They used machines that could pick up brain signals down to the millisecond. They asked participants to report the exact moment they decided which hand to use. Not when they moved. Not when they pressed. When they decided. Here's where it gets weird. The machines were already showing activity before the person said they made the choice. Sometimes a full second earlier. Sometimes 4 seconds. And in the most dramatic cases, up to 7 seconds before. That means your brain starts preparing the move before you are even aware you are making a decision. Think about that. The choice is already in progress. The action already set in motion. But your conscious mind doesn't find out until later. You are not the commander. You are the witness. And this is not some glitch or fluke. The experiment has been repeated over the years using different methods, stronger equipment, more sensitive brain scans. And the result is always the same. The brain decides. Then you catch up, not the other way around. It means what we think of as free will might not be what we assumed. We are not necessarily initiating the action. We are observing it, narrating it, justifying it after the fact. And that hits deep, because everything we've ever done, every major turning point in our life, we thought we chose it freely. But if the choice was already forming before we were aware of it, then how free was it really? That doesn't mean we are robots. It doesn't mean we are just passengers. But it does mean that the conscious part of us, the part that feels like me, is not always the one calling the shots. A huge portion of the process happens backstage, in the dark, outside of awareness. Your brain is constantly processing in the background. It's scanning the environment, comparing past experiences, running predictions, deciding what's safe, what's rewarding, what's familiar. It does this every second, and most of it never reaches consciousness. You don't feel it happening. You don't even know it's happening, but it's shaping everything. From the way you answer a question, to the people you're drawn to the risks you take without knowing why. So when you finally do make a choice, it's not out of nowhere. It's not born in that exact moment. It's the result of 100 invisible calculations that already happened. You just get the headline. This completely rewrites how we think about guilt, habit, discipline, even identity. Because if your brain is starting the decision before you're aware of it, then responsibility becomes more complex. Think about people who act impulsively, people who lash out, people who fall into addiction. It's easy to say, they made a choice. They knew what they were doing, but maybe they didn't. Maybe their brain got there first. Maybe the conditions were already stacked against them before they even felt the urge. That doesn't remove accountability, but it does shift the focus. Maybe real control doesn't come from the moment of choice. Maybe it comes from everything that happens before that moment. What you feed your brain, what you practice, who you surround yourself with, the thoughts you rehearse, the habits you let repeat. Those things become your brain's training ground. They shape how fast it responds, how strong the impulse is, and which direction it leans before your conscious mind even arrives. It's like preparing the soil before a storm. When the rain comes, you don't choose where it lands. But if you shape the ground, you already know which way it'll flow, and that's where your power lies. Not in stopping the decision mid-flight, but in changing the path it takes before it even begins. So yeah, your brain makes choices before you do, but you still have a role, a big one. You're not the spark, you're the architect. You build the landscape. You decide what your brain gets used to, what it sees as normal, what patterns it leans toward, when the moment hits. That moment you think you're choosing something. It's the end of a story your brain's been telling for years, and the craziest part, most people will never realize it. The hum that only some people can hear. There's a sound out there that most people will never hear. But for the ones who do, it never stops. It's low, constant, and feels like it's coming from inside the earth itself. People describe it like a diesel engine idling in the distance. Always there, always humming. But the strange thing is, no one's ever found where it's coming from, and no microphone has ever recorded it. It's simply called the hum. Not very dramatic. But if you talk to the people who hear it, it becomes clear this thing is no small annoyance. It drives people to insomnia, headaches, despair. Some have had to leave their homes, quit their jobs, isolate completely just to get away from it. There are reports of people sleeping in basements, inside cars, even underground, just to find a space quiet enough to escape it. But here's where it gets strange. You'd think it's just some kind of machine noise, right? A factory, maybe. A power plant. But this hum has been reported in quiet towns, in the countryside, even on isolated islands, in places with no heavy machinery, no urban sprawl, no traffic. In fact, one of the most famous cases happened in a town called Taos, New Mexico. Back in the 1990s, dozens of residents started complaining about a low droning sound that no one else could hear. Researchers came in. They set up sensitive microphones, sound mapping equipment, all the scientific tools you'd expect. And what did they find? Nothing. There was no hum, no vibration, no low-frequency tone that showed up on any recording. But the people kept hearing it. Other cases started appearing. In the UK, in Canada, in Australia, same story. A low hum that maybe 1 in 50 people could hear. Same symptoms, same frustration. And every time, the same outcome, no measurable sound. Nothing anyone could trace. This leaves only a few possible explanations, and none of them are comfortable. The first theory is biological. Some scientists think the hum might be coming from inside the human body, something to do with hearing loss or hypersensitivity. Maybe the people hearing it have unusually good low-frequency hearing, and they're picking up distant vibrations that others can't. Maybe it's the brain misinterpreting signals from the ear, like a phantom noise similar to tinnitus. But there's a problem with that theory. If it were just biology, you'd expect it to happen at random in individuals scattered all over the world. But the hum tends to show up in clusters, entire towns, sometimes dozens of people, all hearing the same sound at the same time. And in some places, the hum only starts after a certain year, as if something had been turned on. That doesn't really line up with the idea of random internal hearing issues. The second theory is environmental. Maybe there's a real sound, but it's not coming through the air, it's coming through the ground. Low frequency vibrations, known as infrasound, can travel for miles and still be felt by the body. Not heard through the ears, but sensed, almost like pressure. Things like natural gas pipelines, ventilation systems, even seismic activity can create infrasound. But once again, this doesn't quite fit. Infrasound can be measured, it's well understood, and in most of the places where the hum has been reported, nothing measurable is found. No vibrations, no energy sources, no frequencies in the right range. Even military testing has been ruled out in many cases. The hum persists whether people live near technology or far from it. So what does that leave? Some say it's psychological, that the hum might start as a suggestion. Maybe one person hears it, talks about it, and then others begin to focus on it. a kind of mass attention loop. The more you focus on silence, the more your brain invents something to hear. It wouldn't be the first time the brain has created sensations out of nothing. The placebo effect is real. So are hallucinations in otherwise healthy people under stress. But here's what makes the hum so eerie. The people who hear it, they're often described as calm, rational, normal folks. Not the type prone to delusions. Not attention seekers. Many of them didn't even want to talk about it at first, afraid they'd be laughed at. Some of them only found comfort when they realized others were hearing it too. And then there's the emotional layer. The people who live with the hum often describe it not just as annoying, but menacing. It's not just a sound. It feels like a presence. A pressure, like something is always there, just beneath the surface of awareness. They say it vibrates through walls. It sinks into your chest. It keeps you awake, not just because it's loud, but because it feels wrong, and no one can shut it off. So we're left with a phenomenon that affects a small percentage of the population, can't be measured, can't be recorded, appears and disappears without warning, isn't tied to any specific technology, weather pattern, or geological condition. And yet, it's real enough to ruin lives. Is it a glitch in human perception? A quirk of the brain? A sound so low and so strange that it slips through our normal understanding of noise? Or is it something else entirely? The truth is, no one knows. It's one of those mysteries that science hasn't cracked. Not because it's impossible, but because it slips through the cracks. It hides in the space between what we can measure and what people experience. And in that space, the hum continues, quiet to most, deafening to a few, and still, after all these years, completely unexplained. The child who remembered a past life in detail, but every so often, a story comes along that doesn't just challenge what we believe. It challenges how we know what we know. And that's exactly what happened when a young boy began describing a life he never lived. Not in vague, dreamlike symbols, but with names, places, memories, details that should have been impossible to know. This wasn't a ghost story. It wasn't some blurry internet rumor. It happened in a small village in India. The boy's name was Ravi, 4 years old, bright, healthy, completely ordinary in every way, until one day he started saying things that no one around him understood. He talked about another family, another town. He mentioned a man who had been murdered, and he said, with calm certainty, that the man was him. At first, his parents thought it was a phase, a child's imagination, but the details kept piling up. He gave the name of the town, a place nearly 100 kilometers away. He gave the full name of the man he claimed to have been. He described the street he lived on, the people he lived with, even the shop he ran. And when his parents finally took him to that town, what happened next shook them to their core. The boy led them, down the road, around turns, right to the exact building he had described. It was real. And inside that building, they found the family of a man who had been murdered years before. Exactly as the boy had said, the man's name matched. The details matched. Even the scars on the boy's body lined up with the injuries from the previous man's death. People were stunned. The family of the deceased man didn't know what to think. The boy remembered nicknames, secret family arguments, where money had been hidden. He recognized relatives he'd never met. He asked about things that had happened before he was born in a house he'd never been in until that day. Word spread quickly. The case reached Dr. Ian Stevenson, a psychiatrist from the University of Virginia, who had been studying past life memories in children for decades. Stevenson was known for being careful, thorough, and deeply skeptical. But he traveled to India, met the boy, interviewed the families, and examined the case firsthand. And what he found was hard to dismiss. There were no signs of coaching, no evidence of fraud. The two families had never met before. The boy was too young to have read or researched anything on his own, and the amount of verified detail was staggering, far beyond what even a well-informed adult could fake. Now here's the thing. This isn't an isolated case. In fact, Stevenson documented over 2,000 similar stories across the world. Children between the ages of 2 and 6, usually in cultures that believe in reincarnation, spontaneously remembering lives that were later verified. In many of the cases, the previous person had died suddenly, often violently, and in a strange number of cases, the children had birthmarks or physical defects that matched wounds from the earlier death. Stevenson didn't claim to prove reincarnation. He was cautious with his words. What he said, again and again, was that the data pointed to something happening, something beyond current scientific understanding, something that suggested memory, identity, and consciousness might not be as tightly tied to the brain as we think. And that's where this gets really interesting. Because if these memories can exist outside the lifetime of the body, then maybe consciousness itself isn't born when we're born, and it doesn't die when we die. Maybe it moves. Maybe it continues. Maybe it returns. Modern neuroscience still doesn't fully understand where consciousness comes from. We know it's linked to the brain. We know changes to the brain can change personality, memory, perception. But we don't know how raw experience emerges from matter. We don't know how memory is stored at the deepest level. And we definitely don't know how a child could recall a life that ended years before they were born. Skeptics have tried to explain these cases with more familiar ideas. Maybe the children overheard stories. Maybe they picked up on adult conversations and misunderstood them as memories. Maybe it's all coincidence. But when you listen to the recordings, read the transcripts, hear the children speak in first person about lives that ended in fear or trauma or sudden separation, it doesn't feel like a coincidence. It feels like something else, something old, something we've forgotten how to talk about, and maybe that's why these stories stay with us. Not just because they're strange, but because they tap into something deep, something human. The fear of not knowing what comes next, the hope that maybe something does. And if a 4-year-old can remember the face of another mother, the name of another home, the sound of a life that ended before his began, then maybe the boundary between lives isn't as solid as it seems. Maybe memory lingers longer than we thought. Maybe death is not a wall, maybe it's a door. And maybe, just maybe, someone's already come back to tell us. The storm, that's been spinning for 30 years. There's a storm out there that doesn't make sense. It's not on Earth. It's not even close. It's on a planet over 800 million miles away, and it's been spinning perfectly for more than 30 years. Longer, actually. We just didn't notice until the right eyes got close enough to see it. It sits at the North Pole of Saturn, and it doesn't look like any storm we've ever seen. Because it isn't round. It isn't swirling like a hurricane. It's shaped like a hexagon. 6 perfect sides. Sharp corners, locked in place like geometry frozen in motion. And no one knows why. We first saw it in the early 1980s, when Voyager flew past Saturn and sent back a few grainy images. There at the pole was this shape, almost too perfect to be real. Scientists assumed it was a glitch, maybe a camera artifact, something to do with the light or the angle. But years later, when the Cassini spacecraft arrived and started sending high-resolution video back to Earth, the hexagon was still there. Clear, stable, rotating like a giant mechanical object. Except this wasn't metal. This was wind, clouds, gas, a structure made entirely of atmosphere. 6 sides, each about 9,000 miles long. To put that in perspective, each side of the hexagon is wider than the Earth. The entire shape could fit 4 Earths inside of it. And it doesn't drift. It doesn't wobble. It stays locked in place, spinning with Saturn's rotation in perfect sync. What kind of storm does that? On Earth, storms are messy, chaotic. They swirl and shift. They build, collapse, and rebuild again. Hurricanes change shape. Tornadoes jump from place to place. The atmosphere is full of friction, resistance, terrain. But on Saturn there are no mountains, no oceans, just gas. Endless layers of hydrogen and helium flowing at incredible speeds. The jet streams on Saturn move 10 times faster than Earth's. And near the poles, something strange happens. The air starts to behave like fluid in a lab experiment. Scientists recreated this in a tank. They filled a spinning drum with liquid, then added a faster, moving ring of liquid inside it. And at just the right speeds, something amazing happened. A hexagon formed. Not a perfect replica, but close. The fluid self-organized into a stable, 6-sided shape. But here's the difference. In the lab, the hexagon lasted a few minutes. On Saturn, it's lasted decades. Maybe centuries. Possibly longer than we've been watching. And we still don't fully understand why. Why a hexagon? Why 6 sides instead of 5 or 7? Why that shape? And why there? Some theories say it's a kind of Rossby wave. A giant planetary wave that wraps around the pole, shaped by the speed of the winds and the spin of the planet. Others think it might be tied to deeper layers of Saturn's interior, structures we can't see that influence the atmosphere above. But none of the models fully explain the precision, and no other planet has anything like it. Jupiter has its own polar storms, but they're clusters, ovals, circles, cyclones constantly merging and drifting. Chaotic, the way storms are expected to be, but Saturn's hexagon just keeps going. Same shape, same rhythm, like a planet-sized engine that never breaks down. Cassini even watched it change colors as Saturn's long seasons shifted. Remember, 1 Saturn year equals 29 Earth years. The pole transitioned from blue to gold, not all at once. Slowly, over years, the sunlight returned, the chemistry shifted, and the hexagon transformed, not in shape but in hue. And still it spun, still locked in place. So what does it mean? It reminds us that not everything is random. That nature, even at its most violent, sometimes finds structure, patterns, shapes that should be impossible in chaos. It's almost mathematical, almost elegant, like something carved by intention. But there's no mind behind it. Just forces, temperature, speed, pressure, motion, all colliding in just the right way to create something that looks almost artificial. And that's what makes it unsettling. Because we're used to patterns having meaning. A hexagon on a beehive. That's biology. Snowflakes, turtle shells, flower petals, symmetry always suggests design. But this is just gas, moving air, forming something that shouldn't exist for this long, in that shape, at that scale. And no one is watching it up close anymore. Cassini ended its mission by plunging into Saturn's atmosphere. It was the only spacecraft ever to orbit the planet. And now that it's gone, the hexagon is still there, still spinning, still holding its shape, far beyond our reach. We only caught a glimpse, and it was enough to show us that even in the most alien corners of the solar system, something ancient is at work. Forces we barely understand, behaviors we can't fully predict, a storm that doesn't rage at turns, smoothly, constantly, as if waiting for someone to figure out what it really is. Maybe it's just wind. Maybe it's just physics. But it's also a reminder that even in space, where everything feels cold and distant, there are patterns quietly unfolding, structures hidden in motion, and sometimes, if we're lucky, we catch them in the act of being strange and beautiful at the same time. The equation that allows time travel, everyone wants it to be real. It shows up in movies, in books, in those late-night what-if conversations. But deep down, most of us file it under fiction. Entertaining, but impossible. Because how could you actually move through time the way we move through space? Turns out you kind of can. Not just in theory. In actual math, there's an equation that checks out. And it doesn't just allow time travel. It allows loops. A future that bends back into the past. A version of reality where cause and effect chase each other in circles. And this isn't sci-fi. This comes straight out of Einstein's theory of general relativity. Let's break this down without getting too tangled in formulas. General relativity says that mass and energy can bend space and time. You've probably heard the idea that gravity is just a curve in the fabric of spacetime. Big things like stars and planets warp it. And if something warps spacetime enough, weird stuff happens. Time slows down, light bends, and in extreme cases, spacetime can actually loop back on itself. These loops are called closed time-like curves. They're real solutions to Einstein's equations. Not guesses, not speculation. The math allows for them. They're baked into the same physics that lets us launch satellites and predict black holes. Here's the weird part. In a closed time-like curve, an object can travel in a path through spacetime that eventually brings it back to the exact same point it started from. Not just in space. In time. You could literally return to your own past, and there are multiple theoretical models that create these curves. One of the earliest was something called the Gödel metric, discovered by Kurt Gödel. Yeah, the same guy known for logic and incompleteness. He took Einstein's equations and plugged in the idea of a rotating universe. And boom, time loops showed up. The entire structure of the universe, if it was spinning just right, could bend time into a circle. Then came the Tipler cylinder. Imagine a massive, infinitely long tube spinning near the speed of light. Wrap spacetime around it just right, and you get a loop. A path through time that closes in on itself. Mathematically, it works. There's also the Alcubierre drive, the so-called warp drive. It was originally proposed as a way to travel faster than light by bending space, not breaking physics. But when physicists examined the full geometry, some versions actually allowed for time travel under specific conditions. Again, the math allows it. Even wormholes, those shortcuts through spacetime, can become time machines if one mouth moves faster than the other. Connect the two ends with a tunnel, drag one through space at near light speed, bring it back. And now, stepping into the wormhole means stepping into your own past. This is where things get deeply strange. Because the equations say yes, over and over again. But nature might say no. That's the big question. Just because the math works doesn't mean it can physically happen. Maybe these solutions are real, but impossible to build. Maybe the universe protects itself. Stephen Hawking once proposed something called the chronology protection conjecture, the idea that the laws of physics prevent time travel from happening in practice, even if they allow it on paper. Why? To stop paradoxes. Think about it. If you go back in time and change something, say, stop your grandparents from meeting, you create a loop that erases the conditions that led to you traveling back in the first place. That's the classic grandfather paradox. Logically, it breaks. It's like asking, what happens when cause and effect undo each other? But some physicists say, maybe paradoxes aren't a problem. Maybe time loops follow rules we just don't fully understand yet. Some theories suggest the universe self-corrects, that no matter what you do in the past, you can't change the future that led you there. You'll always end up playing a role in events, not rewriting them. It's called the Novikov self-consistency principle, and guess what? It works beautifully with the math. One researcher, physicist Germain Tobar, ran calculations showing that even if you introduce changes inside a time loop, the loop adjusts itself. You can't prevent the outcome, you just change how it happens. And all of it fits cleanly within the laws of physics. So here we are. Equations that allow time travel, models that support loops, theoretical objects like rotating universes, wormholes, and warp drives that can all lead to the same result. A closed path through time. Is it practical? No, not yet. Maybe never. The energy required to build something like a Tipler cylinder or stabilize a wormhole would be astronomical. Beyond anything we can do right now. Some of the materials might not even exist, but that's not the point. The point is that the universe doesn't rule it out. The rules of physics. The same rules that govern gravity, motion, and energy. Do not say time travel is impossible. In fact, they say it's allowed if you can figure out how. And that changes the conversation. Because time travel isn't just a dream. It's a feature of reality that might be hiding in plain sight, waiting for someone or something to find the right doorway, the right equation, the right moment where cause loops into effect and back again. The jellyfish that lives forever, somewhere in the ocean right now, drifting silently through the water, is a creature that doesn't age. It doesn't grow old. It doesn't slowly wear down like everything else. When the rest of nature moves in one direction, this one does something completely different. When it's close to dying, it just resets, not figuratively. Literally, it goes backward in its life cycle and turns into a younger version of itself. And it can do that over and over again. No countdown, no limit. Just an endless loop of rebirth. Scientists call it Turritopsis dohrnii, but most people just know it as the immortal jellyfish. It's smaller than your fingernail, almost invisible in the water, soft and transparent. Nothing about it looks unusual, but what it does breaks one of the most basic laws of biology. Because life is supposed to move forward. Birth, growth, aging, death. That's the cycle. This jellyfish skips the last part. When it's stressed, injured, starving, or even just old, it doesn't decay. It transforms. Its cells completely reorganize. The adult jellyfish reverts to a polyp, the earliest stage of its life. And from there, it grows up all over again. Like if you, after years of living, could suddenly turn into a toddler, grow back into yourself, and keep repeating the process forever. The way it does this is called transdifferentiation. Instead of healing the way we do, it resets at a cellular level. Its specialized cells, muscle, nerve, digestive, they all change types. They become different cells. It's not repairing damage, it's becoming new. It's not just regeneration. It's full body reboot. And it's not a theory. Scientists have watched it happen in labs. Under a microscope, they've seen the jellyfish break itself down, attach to a surface, and rebuild from scratch. Over and over. No known biological limit. No aging. It's not immortal in the fantasy sense. It can still be killed. If a predator eats it or something destroys it, that's the end. But if left alone, it won't age to death. It just loops. Again. Indefinitely. Think about what that means. Everything we know about life is built around time. Growing up, getting older, slowing down. That constant invisible pull toward the end. But this jellyfish steps out of that current. It's not just unusual. It's a biological glitch, a living exception to how life is supposed to work. And for scientists, that's like a flashing neon sign that says, "Look here." Because if this tiny creature can press rewind on its own body, what else is possible? What can it teach us about aging? About cells, about how time affects life? Aging has always been treated like a one-way street. Cells divide, damage builds up, the body wears down. That's just what happens. But if Turritopsis can reverse that, if its cells can forget what they are and become something new, then maybe aging isn't as fixed as we thought. Maybe it's more like a program, something written into biology, not permanently locked. That's why this jellyfish matters. Scientists are studying its DNA, its proteins, the exact moments when it decides to transform, trying to figure out what triggers it, what switches get flipped. Because humans can't transdifferentiate. Not yet. But if we understood how this jellyfish does it, maybe we could apply that knowledge. Maybe one day we could teach our own cells to reset. Not to live forever, but to slow down the clock. To heal better. To regenerate. Not in science fiction. In real life. And it's not as far off as it sounds. We already know human cells can be reprogrammed in labs. Stem cells are real. Regenerative medicine is real. The challenge is scale, complexity, safety. But this jellyfish, it's proof that the concept works. Nature already built it. It's just hiding at the bottom of the sea. What makes this even stranger is how unremarkable the jellyfish looks. No bright colors, no special markings. It's so easy to miss. But inside that tiny creature is a mechanism no other known animal has, a biological time loop. No finish line, just renewal, quiet, continuous, eternal. It raises questions we're nowhere near answering. Like, if a jellyfish can avoid aging, what else in nature might have that ability, and we just haven't noticed? What other strange creatures are out there quietly ignoring the rules? And deeper than that, if aging isn't set in stone, what does that mean for how we live? How we measure time? How we understand what it means to grow old? Because when something this simple can defeat one of life's biggest limits, it shakes the whole structure of what we assume is normal. This jellyfish doesn't understand what it's doing. It has no brain, no thoughts. It's not making a choice. It's just following the code inside it. A code we barely understand, but the fact that the code exists changes everything. It's a reminder that nature is still hiding secrets. That evolution doesn't always move in straight lines. That sometimes, survival means not just adapting, but refusing to end. So yeah, it's just a jellyfish. But it might be one of the most important animals we've ever found. Because it doesn't just live, it begins again over and over, quietly, forever. The object that vanished from the sky. In space, stars don't just disappear. That's one of the few things astronomers have been pretty sure about. Stars live long lives, and when they die, they make a scene. A red giant swells and sheds its layers. A massive star explodes into a brilliant supernova. Even after the light fades, something is left behind. A neutron star, a white dwarf, maybe a black hole. There's always a trace, a signature, an afterglow. But then this happened. A star just blinked out, completely. No explosion, no dying flash, no debris. It was there, and then it wasn't. This wasn't someone mistaking a star for a satellite or a glitch in the data. It wasn't a telescope error or a misidentification. It was part of a real sky survey, an actual record from over 100 years of observations. Researchers had been comparing old star maps to modern digital ones, trying to find objects that changed, things that moved, dimmed, shifted. Normal stuff. But buried in the data, they found something that made no sense. A star that had been clearly visible in multiple observations in the 1950s, and then never showed up again. Not faded. Not gone dim. Gone. Like someone turned off the light. That alone would be weird, but then they kept looking and found more. Not just one. Several stars that had clear photographic evidence of existing and now can't be found. Anywhere. In any wavelength. Radio, infrared, optical, nothing. It's like they've been erased from reality. And these aren't close by stars that could have shifted out of view. These are distant, fixed stars that shouldn't be able to hide. The energy alone would have left some signature behind, some echo in the sky. But in these cases, the sky is just blank, silent, empty. One of the best-known examples is an object known by its catalog name, and that's all it is now. A name in an archive and a dot on an old image. Researchers looked where it should be with modern telescopes, including some of the most powerful in the world. And there's nothing there. Just empty space where a star used to be. So what happened? That's the question no one can answer. The usual explanations don't hold up. A supernova would have left debris. A black hole formation would have left a visible event. Even a star being consumed by a massive dust cloud would show up in infrared. But here, nothing. These stars didn't die. They didn't explode. They didn't move behind something. They just stopped being there. And yeah, there are possible explanations, but none of them fit cleanly. Some scientists think maybe they were never stars to begin with. Maybe some of these vanished objects were something else, like failed supernovae. Theoretical events where a star collapses directly into a black hole with no explosion. But even that should cause some gravitational lensing, some detectable ripple. And we're not seeing any. Another theory is that we're looking at some rare kind of stellar instability, where a star dims so dramatically, so suddenly, that it just vanishes from sight. But even then, the odds of that happening exactly when we're watching it are microscopic. And again, no energy release, no light curve, no pattern. It's not just unlikely, it's unnatural. And of course, once the natural explanations start to fall apart, the strange ones creep in. There's a hypothesis that's been quietly circulating in the astronomy community. Not because it's proven, but because at some point you have to consider every possibility. It goes like this. If you were an advanced civilization, and you had the technology to build massive structures in space, and you needed enormous amounts of energy, one way to do it might be to completely surround a star, capture every bit of light, absorb all output, a concept known as a Dyson sphere. Now imagine someone actually did that, covered a star entirely in an artificial shell. From our point of view, it would look like that star just disappeared. No light, no heat, no signature. Just a blank spot in the sky. It wouldn't be proof of life, but it would be an engineered absence, a star no longer behaving like a star. And while that theory is still deep in the speculative zone, it's not entirely off the table. The truth is, we don't know what we're seeing. We're just seeing something we can't explain, because stars aren't supposed to just vanish, and yet they did. At least, that's what the data says. This entire mystery has sparked a new kind of astronomy. Researchers are now building catalogs of these disappearing objects, scanning old photos, comparing them to modern surveys, trying to find more vanishing points. The project is even named like a riddle: vanishing and appearing sources during a century of observations. They're not just looking for stars that fade. They're looking for things that defy how we think the universe behaves. Because maybe these are just rare natural events we don't fully understand yet. Or maybe there's something else, something new, something we haven't even named. All we know is this: the sky keeps records, and sometimes it crosses things out without telling us why. The random number generator that predicted 9/11. There's a computer sitting in a quiet lab somewhere that just spits out numbers. That's all it does. Ones and zeros, endlessly, like digital coin flips. Totally random, no pattern, no logic, no meaning. It's called a random number generator, and in theory, it should be the most boring thing in the world. But then something happened. Something that shouldn't have been possible. On the morning of September 11th, 2001 hours before the first plane hit, these random numbers suddenly stopped acting random. Out of nowhere, the stream of ones and zeros shifted into a statistically significant pattern. As if the machine had sensed something, as if the air itself was holding its breath. And then the world changed. Now, before we go any further, you should know, this isn't a one-off. This isn't a myth or an internet rumor. It's part of a real research project that's been quietly running since the late 90s. It's called the Global Consciousness Project. Sounds out there, I know. But the idea is surprisingly simple. Scientists place dozens of these random number generators, RNGs, all over the world, inside universities, labs, private institutions. Each one constantly records a stream of binary data. If human consciousness is totally separate from the physical world, then these machines should always behave the same, no matter what. Just pure randomness. But what if consciousness isn't separate? What if, on some level, thoughts and emotions ripple outward? What if moments of intense global focus, like a major tragedy or celebration, could subtly influence the environment, not in a mystical sense, but in measurable data? That's what they were testing. And the results were strange. The RNGs showed significant, measurable deviations from randomness during events that shocked or unified the world. Not every small event, but massive ones. Princess Diana's death, the Indian Ocean tsunami, the blackout across Europe, Barack Obama's election, and yes, September 11th, the biggest and most haunting anomaly in the data. But here's the part that's hardest to explain. The pattern didn't show up after the event. It started to build before. Hours before the attacks, the data began shifting away from chaos. It was as if, on some deep, unconscious level, the world knew something was about to happen. Not consciously, not with words or images, but with emotion, with fear, with pressure building in the background of the human mind. Now, let's be clear. This doesn't mean the machine predicted anything in the way we usually think of predictions. It didn't say what was going to happen, or where, or when. It didn't beep or send out a warning. It just got weird, quietly, statistically, and only in hindsight did the researchers notice the anomaly. So the question is, what exactly are these machines picking up? Some believe it's just coincidence, that if you monitor enough data streams long enough, eventually you'll see patterns that look meaningful. That's called epiphania, the human tendency to see shapes in randomness, faces in clouds, signals in noise. And yeah, sometimes that's all it is. Pattern recognition run wild, but these patterns, they repeat. And they tend to cluster around moments of intense emotional significance for large numbers of people. The odds of that happening randomly, again and again, are small, very small, and that's what keeps researchers interested. One possible explanation is based on quantum theory, the idea that observation affects reality at the smallest level. That maybe, when millions of people focus their attention or experience the same emotional surge, something in the fabric of space, time responds. It's wild, but it's not pure fantasy. Another theory is that mass consciousness might have a field effect, like a magnetic field or gravity, something invisible but real, capable of nudging physical systems ever so slightly. These machines, by being extremely sensitive, might just be the first tools capable of detecting it. And even if you don't buy any of that, you have to admit, the timing is hard to ignore. Because what do we make of a device designed to be completely random, suddenly behaving less random right before tragedy strikes? What do we make of numbers shifting before anyone knows what's coming? The truth is, we still don't know what consciousness really is. We don't fully understand how thoughts emerge, how emotion takes shape, or what happens when large numbers of people feel the same thing at the same time. Maybe our brains are just isolated machines inside skulls. Or maybe they're part of something bigger, something shared. What if consciousness isn't locked inside us? What if it's more like a signal, broadcast and received, whether we realize it or not? And what if, just for a moment, before the towers fell and the world held its breath, that signal grew louder? Maybe we'll never know for sure. But these machines are still running, still listening, still recording quiet tremors in the data stream of reality. And once in a while they whisper something strange. That something is coming. Before it does, the drug that heals without any medicine. Imagine going to the doctor with chronic pain. Real, constant pain. You've tried everything, physical therapy, anti-inflammatories, even surgery. Nothing helps. Then the doctor gives you one last option. A new pill, small, white. No side effects. You take it for a few weeks, and the pain fades. For the first time in years, you feel better. You sleep better. You move easier. But here's the twist. That pill, it was just sugar. No active ingredients. No medicine at all. And yet it worked. That's the power of the placebo effect. A biological response to something that technically shouldn't work. For a long time, doctors saw it as a fluke, a mental trick, a nuisance in clinical trials. But now we know it's something much more serious, something measurable, and in some cases, something stronger than real drugs. See, placebos aren't just, you imagined it. That's the biggest misunderstanding. The effects can show up in brain scans, blood pressure, hormone levels. They can literally be seen in the body. People given placebos for depression have shown changes in serotonin activity. Patients with Parkinson's given fake dopamine pills have shown real improvement in motor function. Placebos for pain. They trigger the brain to release endorphins, natural opioids, reducing pain signals. measurable, observable, not just in the mind, in the body. Even more shocking, sometimes placebos outperform real medications. In certain trials for antidepressants, people taking sugar pills report nearly identical results to people on actual medication. Some studies show that over time, the brain rewires itself in response to the expectation of healing, like belief itself is the drug. And it gets weirder. Because placebos don't always require deception, researchers have given people pills and flat out told them, this is a placebo. This is fake, it contains no active medicine, and still, it works. Patients with IBS, migraines, even ADHD, have shown improvement after knowingly taking placebos. Just hearing, this might help you, seems to light up something deep in the nervous system. So what's actually going on here? It starts with expectation. When you believe something will help you, your brain starts preparing for that outcome. The body follows that signal, tightening, loosening, releasing chemicals. It's a feedback loop. Your mind anticipates relief, and your nervous system begins behaving as if that relief is already happening. It's not imagination. It's a shift in physiology. But belief alone isn't enough. The environment matters too. The authority of the doctor, the way the pill looks, the ritual of taking it, all of that sends subtle cues to your brain. This is medicine. This is healing. And the brain responds accordingly, like it's been trained to react not just to drugs, but to the entire experience of treatment. That's why red pills tend to be more stimulating. Blue pills are calming. Bigger pills feel stronger. Injections create stronger placebo responses than capsules. Surgery, even fake surgery, where nothing is actually done, can trigger powerful healing responses just because the body believes something meaningful has happened. There's even something called the nocebo effect, the evil twin of the placebo. If you believe a pill will make you sick, even if it's completely harmless, your body can create symptoms. Nausea, headaches, dizziness. Just from the expectation of side effects, that's how powerful belief is. Now, none of this means real medicine doesn't work. It absolutely does. But it means the mind is part of the equation. Every time we take something, we're not just responding to the chemical. We're responding to the story, the meaning we attach to that act, the trust, the hope, the belief that we're being cared for, that something's being done, and when that belief is strong enough, the body follows. So, could we ever harness this? Could we one day prescribe placebos ethically, openly, and still get results? Some researchers think so. They've been developing honest placebo treatments, where the patient knows it's fake, but still takes it regularly as a ritual. And for some people, it works. Even just the act of taking something, knowing it's part of a routine, is enough to calm symptoms, regulate stress, and start healing. The implications are huge. Because if the mind can influence the body this deeply, we're looking at a whole new frontier of medicine. Not as a replacement for real drugs, but as a companion to them. A way to boost results, lower dosages, reduce side effects, heal faster, feel better, all by tapping into the body's own hidden systems. And maybe even deeper than that, it forces us to rethink what healing is. It's not always about fighting something directly. Sometimes it's about shifting belief, creating safety, giving the body permission to reset. Because if a sugar pill, backed by trust, ritual, and hope, can reduce pain, calm anxiety, and change the chemistry of the brain, then maybe the mind isn't just where healing starts. Maybe it is the medicine. The shadow people seen in controlled labs, You're lying in bed, eyes open, but you can't move. There's weight on your chest. You try to scream, but your voice doesn't come. You look toward the corner of the room, and something is standing there. Not a person. Not quite. A figure, dark, featureless, just watching. It doesn't speak. It doesn't move. But somehow you know it sees you. These are shadow people, and for a long time they were dismissed as just nightmares, tricks of the mind. But then science tried to study them, and what they found changed everything. Let's start with what this actually is. The medical term is sleep paralysis. It's a condition where the brain wakes up before the body does. You become aware, but your muscles stay frozen, like you're still dreaming. It usually happens as you're falling asleep or just starting to wake up. And during that moment, when your brain is trapped between dreaming and consciousness, things can get terrifying. But here's the part that science can't quite explain. Across cultures, across countries, across languages, people report seeing the same thing, a presence in the room, usually dark, often humanoid, sometimes wearing a hat, always silent, always watching. Some people feel it climb on top of them. Others say it whispers. Some just feel an overwhelming sense of dread, like they're about to die. These aren't just stories passed around online. These are real cases documented in sleep clinics. People hooked up to brain monitors, heart monitors, cameras, experiencing these episodes in controlled environments. And the moment it happens, you can see it. Heart rate spikes, brain waves light up. Some people cry. Some scream once their body catches up. And after it's over, almost all of them describe the same thing. Something was in the room. Something was there. So here's the big question. What are they seeing? One explanation is neurological. When the brain gets stuck between REM sleep and wakefulness, the dream center, called the amygdala, stays active. It floods the system with fear, because that part of your brain doesn't know what's real and what's imagined. At the same time, the brain's spatial awareness kicks in, trying to make sense of your surroundings. And because you can't move, your mind fills in the blanks. It creates a presence, a shadow, a shape, something to match the fear. But that doesn't fully explain the specificity. Why is the figure almost always dark? Why the feeling of being watched? Why the crushing weight? Why the hat, for God's sake? Why do so many people describe a shadowy man in a wide-brimmed hat? That's where it gets weird. Some researchers think there's a deep, archetypal image burned into human consciousness, a kind of primal fear we all share, one that goes back thousands of years. The predator in the dark, the watcher in the trees, the figure that follows but never speaks, and in moments of vulnerability, like sleep paralysis, the brain summons that ancient fear, not as a memory, as a hallucination, a survival reflex gone rogue. But then, there's another theory, one that creeps up in the fringes of neuroscience and consciousness studies. What if it's not entirely a hallucination? Some scientists believe that during altered states, like sleep paralysis or near-death experiences, the brain becomes hyper, sensitive to environmental input. It starts picking up on things we normally filter out. Changes in electromagnetic fields, subtle shifts in light, maybe even things we don't fully understand yet. Could that explain the sense of a presence? Could that account for people seeing the same shape in different parts of the world, in different centuries, without ever hearing about it beforehand? In Switzerland, one lab used transcranial magnetic stimulation to directly trigger the sensation of a shadow person. They sent a current into a part of the brain responsible for body awareness, and the subject immediately felt like someone was standing behind them. Close. Too close. Even though no one was there. They couldn't see anything, but they felt it. A presence. Real as anything. But here's where it gets darker. In some lab recordings, people have reported seeing actual figures. On camera, under observation. These aren't fake ghost hunting setups. These are clinical settings, wires, EEGs, professional oversight, and yet, there are moments when the subject gasps, starts crying, points to a corner of the room, and even later, in playback, they describe the same thing. A tall, dark shape, motionless, waiting. And sure, you could say that's just a brain under stress. You could say the fear is so intense, the mind paints a picture to match it. But that doesn't make it less real to the person living through it. These aren't stories told for attention. They're usually told with shame, with confusion, with trauma, because when you've seen something like that, even if science explains it, part of you still wonders, was it just my brain, or was it something else? Something that comes when you're too weak to move, too tired to fight. Something that's always been there, just waiting for the right moment, whatever it is, real or not. It leaves people changed. They wake up with tears running down their face. They refuse to sleep with the lights off. They move apartments. They quit jobs. They don't laugh it off. Because when you feel a presence in the room with you, even once, it doesn't matter what science says. To you, it was real. And maybe that's enough. The mind that saw the future in a dream. You ever wake up from a dream so vivid, so specific, it feels like more than just a dream. Not random shapes or symbols. Not some blurry nightmare. I'm talking names, places, exact details you've never heard before. And then, days, maybe weeks later, you see it happen. In real life, most people brush it off. Weird coincidence. A glitch in memory. But what if it's not? What if one person got it so right, so specifically ahead of time, that even scientists had to stop and say, hold on, how? Let me introduce you to a guy named Chris Robinson. British, seemingly ordinary. But he started having dreams, not the kind where you're flying or losing teeth. These were like movie scenes. Vivid, clear, packed with real-world information. And then the things he dreamed would start happening. And I don't mean kind of or close. I mean names of people he'd never met, locations he'd never visited, headlines before they printed, sometimes down to the exact day, over and over again. Naturally, nobody believed him at first. He got laughed at, ignored, dismissed as just another self-proclaimed psychic. But he kept a dream journal, wrote everything down, dates, descriptions, drawings, and that's where things started getting strange, because his logs began lining up with real-world events. Plane crashes, explosions, high-profile deaths. One time, he dreamed about a hostage situation in the Middle East. Days before it was reported on the news. The clothing, the room, even the position of the victim's hands, matched exactly what came out in photos. That kind of accuracy. Hard to ignore. So researchers started to take notice. Not all of them. Most of the mainstream science world kept their distance. But a few brave scientists decided to test him. One of them, Dr. Gary Schwartz, set up a controlled experiment. He wanted to know if Chris could dream about an event that hadn't happened yet, under monitored conditions, and then verify those details later. Here's how it worked. Each night, a location would be randomly chosen from a sealed list. No one told Chris what the location was. No clues, no context, He'd go to sleep, record his dream in the morning, full drawings, notes, everything. And then later, they'd reveal the actual place. And time after time, the details matched. If the chosen location was a train station, he'd sketch a platform, describe the sound of metal and crowds. If it was a park, he'd talk about children playing, trees swaying, the smell of cut grass. It wasn't perfect every single time, but it was close enough, often enough. That probability couldn't explain it away. It defied the odds, and it made people uncomfortable. Because if someone can really see things before they happen, what does that say about time, about the brain, about reality? One theory is that during sleep, the brain drops into a different state, one where linear time doesn't exist the way we think it does. In that deep, disconnected state, maybe your mind can pick up on patterns it normally filters out. Maybe the future, at least parts of it, already exists. And dreams are just tapping into the edge of it. Some scientists believe time isn't a straight line, but a block, a giant chunk of space, time where the past, present, and future already coexist. We're just moving through it like a needle across a record. If that's true, then maybe dreams are like skipping ahead a few tracks. But here's the thing. Chris wasn't just seeing vague images. He was seeing decisions people hadn't made yet. Choices. Paths that weren't locked in. So if he was really glimpsing the future, it raises another question. Is the future fixed or flexible? And maybe that's why this kind of ability, if it exists, is so rare. Because it's messy. It doesn't work on demand. It doesn't always show the full picture. And most of us, even if we dream about something real, forget it within minutes. The brain is great at scrubbing out what it thinks is useless information. But Chris paid attention. He trained himself to remember, to write, to review. And the more he did it, the stronger it got. There's even a name for this in psychology: precognitive dreaming. It's not fully accepted in mainstream science, but it's been studied, and the people who experience it often have two things in common: heightened emotional sensitivity and an ability to recall dreams in extreme detail. Their brains seem wired just a little differently, and it makes you wonder how many of us have had moments like this, where you feel like you've been somewhere before. Heard someone say something before they say it. Got a feeling. A vivid, detailed sense that something's about to happen. And then it does. We chalk it up to coincidence. Déjà vu. Luck. But maybe it's not that rare. Maybe we're all just too distracted to notice. Or maybe we don't want to notice. Because seeing the future, even tiny pieces of it, comes with a weight. If you know what's coming, even a glimpse, what do you do with that knowledge? Can you change it? Should you? Or are you just stuck watching the scene play out, powerless to stop it? Whatever the answer is, Chris Robinson saw something real, over and over again. And whether science ever fully explains it or not, his mind reached across time, in a dream, and came back with proof. The machine that picks up ghost energy. Some machines are built to measure the invisible. Radiation. Static. Temperature changes so small, your skin wouldn't notice them. But then there are moments when those machines start going off in ways no one can explain. No wires. No signal. No living thing in the room. Just a spike. Like something stepped in from the other side. One of the most commonly used tools in paranormal research is the EMF detector. EMF stands for electromagnetic field. In everyday life, these fields are created by electronics, phones, microwaves, circuit boxes, even your Wi-Fi router. and EMF meters are built to detect them. But something weird started happening when investigators brought EMF meters into places that were supposed to be abandoned. Old asylums, shut down prisons, homes no longer hooked up to power, rooms where everything was turned off, and the devices still went crazy. The lights would flash, the numbers would jump, the field would spike, and it always seemed to happen right after someone said they felt watched. At first, people said it was faulty equipment, interference, radio waves. But over time, the pattern kept repeating. Investigators would ask a question out loud, "Is there anyone here with us?" And the EMF meter would immediately respond. Not randomly, not slowly, but instantly, like something heard it, like something was answering. It got weirder when these same spikes lined up with other physical changes. Sudden drops in temperature, breath that turned visible, cameras that lost focus, batteries that drained in seconds. It was as if the environment shifted all at once, like a field of energy moved in, took what it needed, and vanished. That led to a theory. If a spirit or ghost or conscious imprint does exist, maybe it needs energy to manifest. Not just from people, but from the room itself. And maybe when that happens, machines meant to pick up natural signals are catching the side effects. Now bring in thermal cameras. These are used in tons of legit fields: search and rescue, wildlife tracking, building inspections. They detect heat, body heat, machine heat, even subtle warmth left behind on a couch cushion after someone stands up. But in haunted spaces, thermal cameras have recorded the opposite. Not heat, but absence. Cold spots that appear out of nowhere, shapes that move without giving off temperature. Sometimes, these shapes look like figures, heads, shoulders, standing still, or walking, completely invisible to the eye. One of the most famous cases happened during an investigation in a sealed hospital. No people inside. No heating. A thermal camera picked up a cold outline standing next to the investigator. The outline turned its head. The investigator felt nothing. But the thermal camera showed movement. Cold, clear, real. There's no trick to that. No draft makes a human shape and moves it across a floor. That's not faulty wiring. That's something else entirely. And when you match that with EMF spikes happening in the same moment, the odds of it being random drop to near zero. Some researchers started stacking the tools together. EMF, thermal ion detectors, even audio spectrum analyzers that can pick up sounds beyond human hearing. The idea was to catch everything at once, and the data started to pile up. Places people swore were haunted often had measurable disturbances. Not just feelings, not just stories, but evidence. The most interesting part is how consistent it is. You get a high EMF spike, then a temperature drop. Then the gear starts acting up, the camera glitches, the flashlight flickers. The air feels heavier. Every time it follows the same chain, like steps in a pattern. And that's not superstition. That's how science works. Repeatable patterns, measurable change. And if a cold void keeps showing up when a meter spikes and people feel watched, that's worth paying attention to. Now sure, skeptics have explanations, and some are valid. There's always a chance of man-made interference, a buried wire, a hidden radio, a phone tower nearby. That has to be ruled out, always. But once you've cleared all that, and the devices still react, then the mystery gets real. Think about it this way. The human body is electrical. Our brains fire tiny pulses all day long. Our nerves carry those pulses to move, to think, to feel. We're walking energy fields, and when the body dies, that energy doesn't just vanish. According to the laws of physics, energy cannot be destroyed. It changes form. So maybe, in some places, in rare moments, that form still lingers, not as a ghost in the Hollywood sense, but as a field, a presence, something that bends the room just enough for the tools to notice. Because here's the truth: machines don't have bias. They don't get scared. They don't tell stories. They don't chase attention. They just measure. And when more than one starts reacting at the exact same time, in the exact same place, with no clear cause, maybe the machines are telling us what we refuse to believe. That something is there. Something invisible. Something real. And it leaves a trace. The plant that reacts to your emotions. Most people walk past a plant without thinking twice. To them, it's decoration, background, nothing more than a green object that grows slowly and dies quietly. But what if I told you a plant can feel what you're feeling? Not metaphorically, not spiritually, measurably. What if it reacts to your emotions before you even move a muscle? This started back in the 1960s. A man named Cleve Baxter, who was a former CIA interrogation expert, decided to do something unusual. One night, on a whim, he hooked up a polygraph machine to the leaf of a houseplant. Just a regular Dracaena sitting in the corner. He watered it and watched the machine. Nothing happened, as expected. But then he just thought about burning one of its leaves. That's when the needle spiked. He didn't say anything. He didn't touch the plant. He didn't make a move toward it. He simply imagined harming it, and the machine reacted as if the plant had somehow sensed it. That reaction sent him down a path that lasted decades. He tested different types of plants, tried different emotions, used different people, even ran blind experiments. What he found was consistent. The machines kept responding not to touch, but to intention, as if the plants were picking up something deeper than sound or motion, something emotional. Skeptics wrote it off as coincidence or faulty equipment, but over time, other researchers noticed the same strange pattern. When a person enters a room feeling anxious or angry, hooked-up plants show shifts in their electrical activity. And when someone relaxes, meditates, or focuses on sending calm energy, the plants stabilize. These aren't vague feelings or superstitions. The changes show up on real instruments: voltage spikes, shifts in conductivity, a reaction to something invisible, but definitely real. More advanced labs have picked up where Baxter left off, using high-resolution sensors, biofeedback tools, and controlled environments. They've found that plants show measurable responses to human emotion, even from across the room. In some experiments, people were asked to think violent or harmful thoughts toward a plant. The moment that intention formed in their mind, the plant's readings shifted. And the most bizarre part, sometimes those reactions happened before the person physically did anything at all. One experiment involved setting up random timers to trigger a machine that would damage a plant with no humans in the room. Other plants, connected to sensors nearby, still reacted at the exact moment it happened. It was like they were aware of each other, like stress passed from one to another through a medium we still don't understand. It's not entirely far-fetched. Science already knows that plants communicate chemically through their roots. They send signals underground when they're attacked by pests or when nearby plants need help. Some trees share nutrients with others in distress. That's accepted science. But what if that communication also happens above ground? Electrically, emotionally, through a kind of awareness we've never properly measured before now. Some scientists believe we're missing a big part of the picture. That emotion isn't just a mental state. It's a field. a signal. And everything living is tuned into it in some way. Maybe that's why dogs know when you're upset before you say a word. Why babies react to tension in a room even if no one is yelling. And maybe plants, even without brains or nerves, pick up on that same frequency. We're used to thinking of intelligence as something you can see. A face, a voice, a reaction. But awareness doesn't have to look like ours. It doesn't need a heartbeat or a memory. It just needs to respond. And when machines can pick up that response, consistent, measurable, and clearly tied to how a person feels, we're forced to reconsider what life actually means. There have even been stories of plants reacting to specific people. If someone who's harmed them before walks into the room, sensors detect an immediate spike. Not when they move, but the second they appear, as if the plant remembers. Not in the way we do, but through imprint, through stored tension, through energy. Of course, traditional science still debates all of this. It doesn't fit neatly into any known theory, but not fitting doesn't mean it's fake. For centuries, people thought plants were completely passive. Now we know they respond to touch, sound, even light changes measured in milliseconds. They track the sun. They defend themselves. They compete. They adapt. So if a simple leaf hooked to a machine can register fear or comfort or stress, what else are we not seeing? What if emotion is not just inside us, but radiating out like a signal? And plants, sitting there silently, are just better at picking it up. That means they're not just alive. They're aware. They're tuned into the emotional climate around them. And they respond. Every time you walk past. Every time you feel something. Every time you forget they're even there. The star that should have exploded but didn't. There's a star in the sky that's been keeping scientists up at night. Not because it's dangerous. Not because it's new. But because it's breaking every rule in the book. By all known laws of astrophysics, this thing should have exploded already. A massive, violent supernova. Gone. But it's still there, still glowing, still ticking like a cosmic bomb with no countdown. The star is called Betelgeuse. You've probably seen it without realizing it. It sits on Orion's shoulder, burning red in the night sky. It's huge. Over 700 times the size of our sun. If it were placed at the center of our solar system, it would reach past Jupiter. This is not a quiet little star. It's a beast, and it's old. Stars like Betelgeuse don't live very long. The bigger they are, the faster they burn through their fuel. That's just basic stellar evolution. At a certain point, a star like this runs out of hydrogen. Its core contracts. The outer layers swell up. It becomes unstable. And then comes the collapse. Gravity wins. The entire structure implodes, releasing a massive blast of energy. That's what we call a supernova. It's not a question of if. It's just when. But here's where things get weird. Based on everything we know about Betelgeuse, its size, its age, its behavior, it should have already gone supernova hundreds of years ago. Some models say 1,000, some say 500. Either way, we are way past the expiration date. And yet, the star is still there, glowing red, pulsing, unpredictable. Scientists started paying closer attention a few years ago when something strange happened. In 2019, Betelgeuse suddenly dimmed, not just a little. A dramatic drop in brightness that lasted for weeks. Telescopes all over the world turned toward it. People thought this might be the beginning of the end. But it wasn't. After a while, the star just went back to normal like nothing happened. One theory was that a cloud of dust had temporarily blocked the light. Another said the star might be entering a new phase, but neither fully explained it, especially when the dimming happened again and again. This isn't just some faraway light show. When Betelgeuse does eventually explode, it'll be visible from Earth even during the daytime. Not dangerous to us, but unlike anything humanity has ever seen. Brighter than a full moon, hanging in the sky for weeks. An entire star dying in real time, right above our heads. So why hasn't it happened yet? That's the question no one can answer. Some think we're simply lucky. We're catching the last moments of a star's life in slow motion. Others believe we're missing something fundamental about how massive stars behave. Maybe Betelgeuse has more time than we thought. Maybe its structure is more complex. Layers within layers, each delaying the inevitable collapse. Or maybe, and this is the part that keeps people staring at the sky, maybe we don't understand time on a cosmic scale the way we think we do. Light from Betelgeuse takes over 600 years to reach us. So everything we're seeing already happened centuries ago, which means there's a chance it already exploded, and we just haven't seen it yet. Think about that. Right now, as you're hearing this, that star might not even exist anymore. It could be gone, vaporized, just a ghost of light still traveling through space, trickling toward us like an echo. That possibility changes how you see the universe, because it means the sky isn't just a map of what's out there, it's a time machine. Every star, every flicker, every beam of light is a story that already ended, and we're just now reading the last chapter. Still, Betelgeuse refuses to follow the script. It pulses, it dims, it burns unevenly. It expands and contracts in ways that defy the models. It's like watching a volcano rumble for years without ever erupting, and nobody knows why. For all the satellites, telescopes, and math we've developed, there are still things out there that just don't behave the way they're supposed to. This star is one of them. Massive, unstable, past due, and yet it holds. What makes it even more unsettling is the scale. Because if we're wrong about Betelgeuse, we might be wrong about a lot of other things too. About how stars age, about how long we have before one explodes near us, about the patterns we think are predictable. The universe isn't a machine with fixed settings. It's wild, chaotic, and sometimes it hides the most important answers inside a single star, sitting quietly in plain sight, waiting to do something no one expects. So every night, scientists keep watching, not just because it's beautiful, but because Betelgeuse is a riddle, a burning reminder that for all our theories and numbers, space still holds secrets it refuses to share. Until one day, it doesn't. The body that lit up without any source, you're glowing right now. Seriously, your body is glowing in complete darkness right this second. Not in a poetic way, not spiritually, literally, measurably, with light. You just can't see it. That's what makes this so strange. Scientists always assumed the human body didn't emit visible light. Sure, we give off heat. That's infrared radiation. But that's not the same. That's thermal. What we're talking about is visible light, actual photons. The stuff that lets you see everything around you. Turns out, your body is releasing them. Constantly. And this isn't some fringe idea. It's been captured on camera. Researchers in Japan used a hyper-sensitive imaging system, far more sensitive than the human eye, and they put it in a pitch-black room. No reflections, no ambient light, no interference, just darkness and people. And what they saw shocked them. The human body glows, a soft, rhythmic emission of light, peaking and fading throughout the day. Not heat, not spiritual energy, not imagination, just pure, faint bioluminescence. The glow is brightest around the face, particularly the cheeks and forehead, and it changes depending on the time. In the afternoon, the body shines the most. At night, it dims. But the wild part is what causes it. Your cells produce this light through a natural process. As your body metabolizes food, oxygen reacts with enzymes and molecules inside your cells. This creates a small burst of energy, and sometimes that energy releases a photon, a tiny packet of light. These are called biophotons. They're not strong enough to see, but they're absolutely there. Now, that's already cool. Your body is glowing from the inside out because of how it breaks down energy. But here's where things go next level. The glow isn't random. It changes with your state of mind. When you're relaxed, the body emits fewer photons. When you're stressed, anxious, or even mentally overactive, it emits more. Your emotional state shifts the intensity of the glow. When people meditate, their photon emissions drop. When people are sick or in pain, those emissions can spike in strange patterns. The glow acts like a mirror of what's happening beneath the surface. This isn't just a body thing either. All living organisms emit biophotons. Trees, fish, bacteria, even single-celled organisms. Life, it turns out, glows. Always has. We just couldn't see it until recently. The question is, why? Some researchers believe biophotons might play a role in how cells communicate with each other, not just through chemicals or electrical signals like we've always assumed, but through literal flashes of light. These photons could act like a silent messaging system, synchronizing biological rhythms, activating responses, or even transmitting information across tissues. It would mean your body isn't just reacting with molecules. It's talking to itself with light. That sounds unbelievable, but the data keeps piling up. In highly controlled experiments, scientists have found patterns in the photon emissions, patterns that suggest coherence. Meaning, they're not just random flashes. They're structured, organized, like the pulses of a laser. And coherent light, in physics, always means intention. Some kind of order, some kind of signal. Even more bizarre, this glow might hold medical potential. Some studies suggest we might be able to diagnose diseases based on changes in biophoton output, before symptoms appear, before anything shows up in blood work. Cancer cells, for instance, emit different photon signatures than healthy ones. In theory, if you could map this light in detail, you could spot problems way before they show up in scans. You'd be reading the light of the body in real time. There are even early experiments with people learning to influence their own glow. Monks trained in deep meditation have shown increased control over their biophoton output. Not drastically, but measurably. Just by shifting their mental state, their bodies glow brighter or dimmer under the camera. It's subtle but consistent. As if awareness itself affects the light, this leads to some deep questions. What if consciousness isn't just thinking? What if it radiates? What if emotion and thought don't just exist in the brain, but ripple outward, changing how your body emits light? Not in a symbolic way, in a real, physical way. Think about the implications. If your cells are constantly emitting light, and that light is affected by how you think, then your internal world might be projecting something into space around you all the time. Something invisible to the eye, but very real. A glow that tells the truth about how you're doing before your words ever do. We're so used to thinking of light as something external. The sun shines. A bulb glows. But this flips everything, because you glow too. You always have. From your first breath to your last, your body radiates a story in photons. Every thought, every heartbeat, every inhale, it all glows. Most people will never see it, but it's there. And maybe, just maybe, this glow isn't just a side effect. Maybe it's part of what makes you alive, part of a much older language your body has been speaking all along. The memory that was never real. There's a memory in your head right now that never actually happened. You'd swear it did. You remember how it looked. Maybe how it felt. You're sure of it, but it's wrong. And what's worse, millions of people remember that exact same false thing. This isn't just some random brain glitch. This is something much stranger. It has a name. It's called the Mandela effect. Now, if you've never heard of that before, here's how it got the name. Back in the early 2000s, a writer named Fiona Broome noticed something weird. She remembered Nelson Mandela dying in prison in the 1980s. She remembered the funeral, the mourning, the news coverage. All of it. But Mandela didn't die in the 80s. He got out of prison, became president of South Africa, lived until 2013. It wasn't just her. Other people remembered it too, thousands of them. People from different countries, different backgrounds, all absolutely sure that Nelson Mandela had died decades earlier. All wrong. That would be strange enough on its own. But then it started happening with other things. Ask yourself this. How do you spell the cartoon Berenstain Bears? Go ahead, say it in your head. Most people swear it's spelled Berenstein, with an E and an I, but it's not. It never was. It's Berenstain, with an A. How about the Monopoly Man? The guy on the box. Does he wear a monocle? You can picture him with one, right? Except he never had a monocle. Not in any version. People will argue that to the ground, until they look it up. There are dozens of examples like this. Famous quotes that were never said, movie scenes that don't exist, company logos that seem to have subtly changed. People feel like they slipped into a different version of reality. Like something in the past quietly rewrote itself. But this isn't science fiction. This is psychology, and the Mandela effect hits something deep in how your memory works. Here's the part most people never realize. Your memory is not a hard drive. It doesn't record things perfectly and play them back. It's more like a puzzle. Every time you remember something, your brain reassembles the pieces based on what you think happened, not what actually happened. It fills in gaps, it smooths over edges, it updates details. And the more confident you feel in a memory, the more likely it is that your brain has already rewritten it. But that doesn't explain why millions of people are misremembering the same thing in the exact same way. That's where it gets weirder. Some researchers think it comes down to shared culture, the way media, language, and visual cues prime our brains to expect certain patterns. For example, the name Berenstain feels more familiar to people because it sounds like other names they've heard. Einstein, Frankenstein, Goldstein. Our brains grab the most familiar pattern and lock it in, even if it's wrong. But then there's the deeper question. If so many people remember the same false event, at what point does it feel real? If you remember Mandela's funeral, and your friend remembers it too, and strangers online remember it the same way, it stops feeling like a mistake. It starts to feel like a missing history. Like maybe the world changed and no one told you. Some people go further. They believe these shared false memories are evidence of alternate realities. That we somehow jumped timelines. That somewhere out there is a version of the world where Mandela did die in prison, where the Monopoly man wore a monocle, where it really was Berenstein. And for some reason, part of your brain still remembers the version you came from. It sounds wild, but here's the thing. No one can disprove it. We know reality is stranger than we ever thought. Quantum physics already tells us particles can be in two states at once. That the act of observing something can change its outcome. That time doesn't work the way we think it does at the smallest scales. So when you stack that up against millions of people sharing a false memory, is it really so crazy to think something else might be going on? And maybe it's not about jumping between worlds. Maybe it's simpler than that. Maybe memory is less about what happened and more about what we collectively believe happened. In other words, memory is not private. It's social. We build it together, and sometimes we build something that never existed. The Mandela effect forces you to confront the possibility that your sense of certainty, the thing that makes you say, "I know what I saw," might be the most unreliable tool you have, because you don't just remember facts, you remember feelings, context, expectations. And if your brain is filling in those blanks the same way as everyone else's, then who's to say what really happened? You've probably had a moment like that before. A memory you would have sworn by, only to be proven wrong in the most undeniable way. And when it happens, it shakes you. Because if that memory wasn't real, what else isn't? The simulation theory, that can't be debunked. You ever get that feeling that something is just off? Like the world is a little too perfect in some places, too broken in others. Like things repeat. Patterns show up where they shouldn't. People think the same thoughts. Coincidences stack up. And you can't explain it, but it all feels strangely designed. That's the core of the simulation theory. The idea that this reality, everything you see, touch, feel, your entire life, is not base reality. That it's all part of an artificial environment, a highly advanced simulation. Like a game, but not the kind you can just turn off. You are inside it. You are part of it. And here's the part that breaks your brain. There may be no way to prove you're not. This theory exploded into the mainstream after a paper by philosopher Nick Bostrom in 2003. He laid it out in the simplest, scariest way possible. He said one of three things must be true. 1. Human civilization will go extinct before it develops the tech to simulate conscious beings. 2. We will choose never to do it. Or 3. We already did, and we are inside one of those simulations right now. And if option 3 is true, then the number of simulated minds could vastly outnumber the real ones, which means the odds that you are one of the originals, the ones outside the simulation, are close to zero. Now that's a philosophical bomb, but here's where it gets wild. The math backs it up. Modern computers are already capable of simulating billions of particles. Physics engines in video games are getting terrifyingly realistic. AI is learning to respond, adapt, even generate entire worlds in real time. Now fast forward 100 years, 1,000, 1,000,000. Imagine what a civilization with that kind of tech could build. Entire universes, fully detailed, with their own laws of physics, own biology, own history. And here's the kicker. If that simulation includes conscious minds that believe they are real, how would they know? You can't compare your world to the one outside if you've never seen the outside. That's the trap. We could be running on a machine the size of a backpack, or a particle floating in some alien supercomputer, or the dream of something beyond human comprehension, and we would have no way of proving otherwise. But it's not just philosophy or sci-fi anymore. Physicists have started looking for glitches, actual measurable signs that reality has a limit. Some think we may find proof in the structure of space, time itself, like pixels on a screen, a maximum resolution, some tiny grain to the universe that hints we're inside a rendered environment. One of the most interesting clues: the speed of light. Nothing in the universe can move faster than it. That's the rule. But why? Why is there a speed limit at all, unless we're in a system that can only update so fast? Like a frame rate, like the render distance in a game engine. You can't move faster than the system can load the next scene. Some quantum physicists are even exploring the idea that matter is just information, that particles don't exist in a specific place until they're observed. Like a program only loads what the player looks at. The rest just sits there in potential, waiting to be called. You think you're looking at the world, but maybe the world is looking back, deciding what to show you. And then there's déjà vu. That eerie feeling you've been here before, that you've lived this exact moment. What if it's not a glitch in your brain? What if it's an actual glitch in the code? A skipped frame, a recycled memory, a rendering hiccup that your mind catches for just a second before the system corrects itself. People laugh off the simulation theory because it sounds too strange. But so did quantum mechanics, so did relativity, so did the idea that the Earth orbits the Sun. The more we learn about the universe, the more it behaves like a complex computational structure. Rules, constants, algorithms that govern everything. So maybe the question isn't, are we in a simulation? Maybe the real question is, why? Why simulate this? Why create a world with love and war and heartbreak and beauty? Why design humans that suffer, or hope, or wonder if they're even real? Some believe it's a test, a learning environment, a sandbox to grow in. Others think it's entertainment, a story being played out over and over. Or maybe it's just curiosity. We simulate things all the time. We create worlds. Maybe someone did the same to us. Here's the part that messes with you. There is no definitive test. If the simulation is perfect enough, every attempt to prove it would just be part of the script. Every doubt, every question, every breakthrough, all of it baked into the code, and maybe the only way to know the truth is to leave it, which we can't. So you wake up, you brush your teeth, you go about your day, and somewhere in the back of your mind, you wonder, is this all real? Or just incredibly well rendered? And if it is a simulation, would you want to know? The clock that ran backward in an experiment. So there was this experiment. It didn't make headlines. Most people have never even heard of it. But what happened inside that lab bent reality in a way that almost no one can explain. Because under controlled conditions, real instruments, real scientists, a clock appeared to run backward, not metaphorically, not in a dream. A real, functioning atomic scale clock showed signs of time reversing itself. And what's even stranger, it only happened when the system was being watched. Let's back up for a second. Most of what you understand about time probably feels simple. The past is behind us. The future's ahead. Time moves in one direction, like a river. Straightforward, right? But in physics, especially quantum physics, it's anything but. At the smallest scales of reality, particles behave like probability clouds. Not solid little dots. They exist in a kind of blur where nothing happens until something interacts with them, until a measurement is made. This is called the observer effect. And it's one of the weirdest things we know about how the universe works. because just the act of observing, just looking, changes what's real. Now combine that with another strange property of quantum mechanics: time symmetry. See, the fundamental laws that govern particles don't actually care which direction time flows, forward or backward. They work the same. That's not just theory. It's built into the math of quantum field equations. So the big mystery is, if the rules don't care which way time goes, why do we only ever see it move one way? This is where the experiment comes in. A few years ago, physicists at the University of Chicago were studying time reversal in a highly controlled quantum system. They were using a kind of synthetic lattice. Think of it like an artificial environment made of ultra-cold atoms, arranged so precisely they behave like a crystal made of light. They were looking for asymmetries, moments where the usual flow of time could be nudged or warped or even, just maybe, reversed. They created a system that should have obeyed normal entropy, the usual rule that systems move from order to disorder. But in this case, under specific observation, the system appeared to go backward, like it was reordering itself, as if the natural decay had reversed course. It wasn't a trick of the eye. They were using instruments built to detect energy states, motion, and thermodynamic behavior, and what they saw broke expectation. One of the clocks they were using, not your average wall clock, but a timing mechanism based on atomic interactions, showed evidence of time inversion, something that shouldn't be possible. So what could cause that? Here's one idea. The entire system was in a quantum state of superposition. That means multiple potential outcomes were alive at once. And the moment the observation took place, the wave function collapsed. But because of the unique setup of the environment, the collapse didn't behave like normal. It folded backward, like rewinding a tape just for a moment. But it gets weirder. They repeated the experiment, slightly changed conditions. Sometimes the reversal didn't happen at all. Other times, it was more dramatic. The common factor, the thing that made it happen, was how and when the system was being watched. That's the part that shakes the whole thing. Because if time can run backward, even briefly, even in specific quantum conditions, and only when observed, what does that say about the nature of time itself? What does it say about us? Maybe we've been thinking about time all wrong, not as a strict river that flows in one direction, but more like a field, a structure, something that can bend, loop, even break, depending on how it's touched. Maybe our consciousness isn't just moving through time. Maybe it's shaping it. And if that's true, then you have to wonder, how many times have we accidentally made time go backward and just not noticed? We think time is constant. But even Einstein proved that's not true. Time passes differently depending on how fast you move or how much gravity is pulling on you. GPS satellites have to correct for this constantly, or your phone wouldn't know where you are. That's basic relativity. But on the quantum level, time might not even be real in the way we think it is. There's a growing belief among physicists that time is emergent, that it's not a fundamental part of the universe, but something that arises out of other relationships, like heat or pressure. And if time is emergent, then it can be broken, disrupted, reversed, at least for a few billionths of a second, in the right lab, under the right conditions. So imagine this, a sealed lab, supercooled atoms suspended in a lattice of light, a quantum system humming in complete stillness. Scientists lean in to observe. Instruments activate. And in that tiny moment, so small you'd miss it if you blinked, A clock quietly runs backward. Then everything snaps back to normal, like nothing ever happened. Except now we know. Time can bend. It can slip. And maybe if you push hard enough, it can break. The human who doesn't feel pain or fear, you break your arm. Bone snapped clean in two. But you feel nothing. No sting. No ache. No jolt of pain telling you to stop. You just notice it's broken. Now imagine being in danger. Something life-threatening. A wild animal. A car spinning out of control. But instead of your heart racing or panic setting in, there's only calm. Your body doesn't even flinch. That's not science fiction. That's a real person. Her name is Jo Cameron, a schoolteacher from Scotland who lived most of her life completely unaware that she was different. Until doctors realized something very strange. She doesn't feel pain. Not heat. Not cuts. Not even the burning sting of chili peppers. Her skin barely registers it. She also doesn't feel fear. Surgeries without painkillers. No anxiety before speaking in public. No panic in emergencies. It's like the usual alarms that scream in the human brain, just never got installed. And here's the wild part. Scientists figured out why. Jo has a mutation, a tiny change in her DNA, specifically in a gene called FAAA, which normally regulates pain, mood, and memory. But Jo's version doesn't work like everyone else's. And even more surprising, they found she's missing an entirely new gene they hadn't even cataloged before. They named it FAAH-OAT. Without the normal function of this system, her brain just doesn't process pain or stress signals the way most people do. Her body makes its own internal painkillers at levels far beyond what's typical. Endocannabinoids that flood her system and blunt every warning signal. But what happens when your warning system is turned off? Pain exists for a reason. It keeps us alive. It's not just there to annoy us. It tells us when something's wrong. A cut, a burn, a disease, a broken bone. It tells you to move your hand off the hot stove, to stop walking when your foot's injured, to go to the doctor when something's not right. Without pain, Jo has suffered serious injuries and didn't even notice. Burns, cuts, even surgeries where most people would be in agony. And she felt fine. That sounds like a superpower until it isn't. She once smelled burning flesh and realized it was her hand, still on a hot pan. She had no idea. That's the trade-off. You're fearless, but also unaware. Your body can break down silently, and you wouldn't know until it was too late. Still, scientists are fascinated by her, because she's not numb in the way some people with nerve disorders are. Her nerves function. She can feel texture, pressure, even temperature, but she just doesn't register discomfort. And emotionally, she's wired for calm. Her stress hormone levels are incredibly low. She's happy, chill, peaceful, even in situations that would send most of us spiraling. And that's what got researchers thinking. What if the key to anxiety, chronic pain, maybe even depression, is locked inside this gene? What if this mutation could be studied, harnessed, even replicated? Not to make people numb, but to help people who are drowning in emotional or physical pain. Right now, millions of people suffer from chronic pain. It ruins lives. Every movement hurts. Every step is a struggle. Opioids help, but they come with addiction, side effects, and a high risk of overdose. But Jo's biology may point to a completely different solution. A pain-free painkiller. A drug that mimics what her body already does. Turns off the suffering without turning off everything else. And on the mental side, imagine treating anxiety or PTSD by quieting the circuits that create fear. Not numbing someone completely, just dialing down the part that's always on high alert, giving the brain some peace, some space to breathe. This isn't just theory. Jo's genetics are now at the heart of ongoing studies. Her cells are being used to map how the FAH system works in detail. What switches get flipped? What chemicals get released? And what it would take to do it in others. But here's the deeper question. What is it like to live without fear? Jo doesn't get anxious. She doesn't overthink. She doesn't dread the future. And it's not because she practices mindfulness or trains her brain. Her brain just doesn't light up the same way. Scans show that the regions tied to fear and threat response are unusually quiet. She says she lives in the moment, and not in the self-help Instagram kind of way. Truly, biologically, she is here, now, without panic or stress about what's next. That's hard for most of us to even imagine, because fear is stitched into everything. Our decisions, our caution, our hesitation, even our creativity. It's the fire behind progress, and the cage that holds us back. Take it away, and what's left? Would you feel free or lost? Jo seems happy, genuinely, effortlessly happy. She never knew anything was missing. Never thought she was special. But her body holds answers to some of the hardest questions in medicine, mental health, and human behavior, all from a mutation no one even knew existed until now. The light that floated inside a plane. Picture this. You are 30,000 feet in the air, sitting by the window of a commercial airplane. Nothing out of the ordinary. The hum of the engine, the clouds below, and then something impossible. A ball of light about the size of a grapefruit floats down the aisle. Not a reflection, not a trick of the eye. A glowing orb, bluish, white, smooth, silent, hovering inside the cabin. It drifts slowly past passengers, pulses once, then vanishes. No sound, no smell, no trace. This wasn't a story passed around by friends of friends. It was caught on camera, studied, and it fits the description of one of the rarest, most mysterious natural phenomena ever recorded. Something called ball lightning. And to this day, science still doesn't fully understand what it is. Ball lightning is one of those things you hear about and assume has to be a myth. Because it breaks the rules. It doesn't flash and vanish like normal lightning. It hovers. It moves horizontally. Sometimes it passes through solid objects, glass, walls, even metal. It has been reported floating into people's homes, bouncing across the ground, or even entering aircraft mid-flight. And it's not a new idea. Reports of ball lightning go back centuries. Pilots in World War II saw glowing orbs flying alongside their planes and called them Foo Fighters. Russian cosmonauts claimed to witness similar lights in space. And in rare, documented cases, ball lightning has even caused damage, burn marks, explosions, electrical surges. But here's the part that gets weird. No two sightings are exactly the same. Different colors, different lifespans. Some vanish instantly. Others linger. Some explode. Others blink out like a candle. So the question becomes, what is it? Is it plasma? A chemical reaction? A magnetic field knot? The truth is, no one really knows. Scientists have tried to reproduce it in labs, and a few experiments have come close. One Russian team managed to create something similar using microwaves focused onto a small spot. The resulting orb hovered for a few seconds and then dissolved. But that required precision equipment, controlled environments, and intense energy. So how does that explain a ball of light floating down the aisle of a passenger jet? Back to the incident. It happened over China. A commercial flight, routine in every way, until the pilots noticed something strange. An intense flash outside the cockpit, followed by a low-frequency vibration. They thought it was a lightning strike, not that uncommon at high altitudes. But then a small orb of light appeared near the front of the cabin. Witnesses say it floated slowly, in complete silence, straight down the aisle. Passengers stared in shock. Some grabbed their phones, and someone captured it. Frame by frame, you can see the orb's soft glow, not flickering, not shaking, steady, controlled. It moved almost like it had intent, like it was curious. And then, just as it reached the midpoint of the cabin, it faded. No bang, no smell of ozone. Nothing burned. Later inspection showed no damage to the plane. No sign of electrical faults, and no way, by standard physics, that a floating ball of plasma could form and hover inside a sealed, pressurized metal tube flying through the sky. But it happened, and it wasn't the first time. In 1963, a Soviet airliner experienced something eerily similar. During a thunderstorm, a glowing sphere the size of a basketball reportedly entered the cockpit, hovered near the control panel, then passed through the fuselage and exited the plane, leaving a clean hole behind, like it had phased through the metal. In both cases, experts were baffled. No known lightning behavior could explain it. And yet, the evidence kept mounting. Some physicists believe ball lightning might be an exotic form of plasma stabilized by its own magnetic field. Others suggest it could be a product of quantum-level electrical discharge, a rare, self-sustaining reaction between atmospheric ions and electromagnetic waves. There are even theories that it's not entirely physical, that what people are seeing could be something that slips between energy and matter, something we don't have the language or instruments to fully capture yet. And then, there are the fringe theories. Some say ball lightning could be a natural manifestation of high-energy portals, micro-wormholes, even a kind of atmospheric consciousness. Yes, it sounds out there. But when something keeps showing up, defies replication, and appears intelligent in how it moves, the theories get stranger. Especially when science has no firm explanation. Still, what keeps this grounded in reality is the documentation. We have the videos, we have photos, and we have first-hand accounts that all point to the same unnerving truth. This is real. Imagine sitting on that plane, watching this thing float past. No sound, no turbulence. Just a slow, pulsing orb in the aisle. No one knowing what it is. No one able to stop it. And then gone. It's moments like this that remind us how little we really understand. The sky isn't empty. The air around us isn't silent. There are forces at work. Some explainable, some not yet, that don't care what we think we know. We like to believe we've got the universe figured out. But every once in a while, a light drifts by and says otherwise. The frequency that changes your mind instantly. You ever hear a sound and just feel different? Not because of the lyrics, not because of the beat, but something deeper, almost physical, like your brain just shifted gears. You were anxious, now you're calm. You were tired, now you're wide awake, and you have no idea why. That feeling isn't just emotional. It's electrical, because your brain doesn't just think in words or pictures. It thinks in waves. Literal electrical pulses firing across billions of neurons, and the speed of those pulses, the frequency, is what determines your state of mind. And here's the twist. That frequency can be changed. Not with drugs, not with therapy, with sound. This is not science fiction. This is a real, tested phenomenon called brainwave entrainment. And it works faster than most people think. You hear a certain tone, your brain starts sensing to it. almost like matching a rhythm. Like how you unconsciously tap your foot when you hear a beat. Except this time, your brainwaves are tapping along too. Here's how it works. Your brain operates in different frequency bands. There's delta, super slow waves, like when you're in deep sleep. There's theta, the dreamy, meditative state. Alpha, calm but alert. Beta, focused and engaged. And gamma, hyper-aware, peak concentration. Now normally your brain moves between these states on its own, but audio tones, very specific ones, can gently guide it. They don't force anything. They just encourage your brain to follow the beat. And it does. Because your brain is naturally wired for rhythm. There are two common methods that do this. The first is called binaural beats. It works like this. You wear headphones. One ear hears a tone at, say, 200 hertz. The other ear hears a tone at 210 hertz. Your brain doesn't hear two separate tones. It hears the difference, 10 hertz. And that internal rhythm becomes the frequency your brain starts to mimic. So if 10 hertz corresponds to an alpha state, relaxed but awake, your brain starts to slow down and settle into that calm zone. No pills, no guided meditation, just a tone. The second method is isochronic tones. Single tones that pulse on and off at a steady rate. No headphones needed. They're more direct, more intense. And they've been shown to affect alertness, mood, even memory. Now, before you think this is just some fringe audio trick, listen to this. In peer-reviewed studies, people who listened to alpha wave frequencies reported reduced anxiety within minutes. Brain scans showed decreased activity in stress-related regions. Other studies found improved focus and working memory after exposure to beta frequencies. Some experiments even showed that theta wave stimulation helped people reach deeper levels of meditation than they could on their own. And it's not subtle. You can actually feel the shift. Ever put on a track labeled deep focus or meditation and suddenly feel your breathing slow down? Your thoughts get less frantic. That's not just the placebo effect. Your neurons are sensing to a new tempo. It's like flipping a switch in your mind, a gentle override of whatever noise your brain was stuck on. And here's where it gets wild. These frequencies don't just change mood, they can change perception. In some experiments, people exposed to theta waves reported heightened creativity, more vivid mental images, even spontaneous emotional memories. Others listening to gamma frequencies showed increased ability to process complex information and notice tiny details they'd normally miss. And this opens up some really strange doors. Because if sound can change your mind so quickly, what happens when you use it intentionally? Every day, can you train yourself to enter flow state on command? To calm anxiety in seconds? To fall asleep faster than your body normally would? Some people are already doing it. Athletes use it before competition to reduce nerves and lock into focus. Therapists are starting to use it alongside traditional treatment for trauma, addiction, and depression. Even tech companies are experimenting with it to improve concentration in high-pressure environments. And of course, there's the darker side. Because if sound can change your state, someone could use it without you realizing. Not to hypnotize you, but to make you more relaxed, more agreeable, or even more anxious. Supermarkets already use specific frequencies in background music to keep shoppers in the store longer. Casinos play tones that subtly mess with your sense of time. It's all very quiet, but it works. And that's the unsettling part. Your mind isn't as locked down as you think. It's reactive, responsive, tuned to frequencies you don't even consciously register. And once you realize that, once you understand that your thoughts can be nudged by invisible rhythms, it makes you question how many of your moods were really yours to begin with. Here's the real question. If a simple tone can pull you out of anxiety, or make your brain more creative, or help you sleep, why are we not using it more? Why is this not common knowledge? Maybe because it sounds too simple. Play a sound, change your mind. But sometimes the most powerful tools are the ones that don't need explanation. You feel it instantly. No convincing required. One tone, one frequency. And suddenly you are not the same. The experiment that proved reality isn't solid. You think you're sitting still. You think your hand is solid. The chair you're in, the screen in front of you. They all feel real, right? Tangible, physical. You can knock on them, push them, break them. That's reality. Or at least that's what it looks like. But what if I told you that's not true? What if, underneath everything you see, everything you touch, there's nothing, no structure, no substance, just empty space, vibrations, probabilities? What if the world you know isn't solid at all? That's exactly what quantum physics discovered. And it broke everything we thought we knew about reality. Let's talk about the experiment. The one that changed everything. The one that scientists call the double-slit experiment. Simple setup. Imagine you're firing little particles, say, electrons, at a wall. But in front of that wall, there's another screen with two narrow openings in it. Two slits. Now here's the logic. If electrons are little solid objects, like tiny balls, they should go through one slit or the other. Right? And on the back wall, you'd expect to see two stripes where the particles landed. That makes sense. But that's not what happened. What scientists saw was a pattern of interference. A ripple effect, like the electrons were behaving like waves, not particles, like they were going through both slits at the same time, interfering with themselves. It gets stranger. So they said, okay, let's observe this. Let's place a detector at the slits and see which one the electron actually passes through. Let's catch it in the act. And the moment they observed it, the wave collapsed. The interference disappeared. Now it acted like a particle, a tiny ball, two stripes again. So just by looking, just by measuring, the electron changed its behavior. It's like the universe noticed it was being watched and decided to act differently. Think about what that means. When unobserved, matter exists as a probability, a wave of potential outcomes. When observed, it becomes real. It picks a side. It becomes a solid point. But only because something looked. Now pause right there. That's insane. Because this doesn't just apply to electrons. This isn't about subatomic quirks that don't matter to daily life. This is the foundation of everything. At the smallest level, all matter. Every atom in your body, every drop of water, every tree, every planet, is mostly empty space, surrounded by particles that don't even act like particles. They act like possibilities. You're not made of solid stuff. You're made of energy behaving like matter, only when necessary. And the double-slit experiment didn't just suggest this, it proved it. This is why quantum physicist Niels Bohr once said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." Because this is not how the world is supposed to work, but it's how it does. Let's go even deeper. Some scientists wondered, could consciousness be involved? Could the act of observation, the presence of awareness, actually shape physical reality? Now, that's still debated, but some experiments go further. In delayed choice experiments, the decision to observe or not is made after the particle has already passed through the slits. And still, the outcome changes, which suggests that reality itself isn't locked in until the moment it's measured. And that time doesn't behave the way we think it does. In other words, what's real doesn't become real until something or someone checks. Now imagine the implications. If observation can change the outcome, what else is being shaped this way? Does reality shift depending on how it's being seen? Could your consciousness, your thoughts, your attention be subtly choosing outcomes in ways you can't measure? We don't fully know, but we do know this under a microscope. Nothing is stable. Nothing is solid. Zoom in close enough, and your hand isn't made of matter. It's atoms. Then it's protons and electrons. Then it's quarks. Then it's just waves. And then it's nothing. Just fields. Fluctuations. Information. So when you touch the world, what are you touching? Not walls. Not objects. Not matter in the way you think of it. You're touching probabilities. You're surfing a quantum field, and your perception, your consciousness, is what turns that ocean of potential into the experience of being human. It's not just poetic. It's physics. And it's terrifying, and beautiful, and humbling all at once. Because for all the technology we've built, for all the machines and microscopes and measurements we have, reality itself is still outpacing us. It's still hiding things we don't understand. Not out in the stars, but here, right in front of us, inside us. You look around and think this is solid, this is stable. But it's not. It's dancing. It's shifting. It's pretending to be still so your brain can process it. But underneath it all, nothing is sitting still. Nothing is settled. The world is made of ghosts, and you are one of them. The area where gravity works differently, there's this stretch of road. Middle of nowhere. Trees on both sides, no wind, no weird machinery, just dead silence. You pull your car up to the base of a hill, put it in neutral, let your foot off the brake, and it starts rolling uphill. Not fast, not violently, but definitely up. Against gravity, with no engine, no push, no explanation. People freak out the first time they see it. They jump out of the car thinking they're hallucinating. They check the tires. They grab a level to test the angle of the road. Some even bring GPS equipment. But it doesn't matter, because the car is going the wrong way. This place is one of dozens across the world. Magnetic Hill in India, Gravity Hill in Pennsylvania, Electric Braid in Scotland. There's a road in South Korea where water flows uphill, not downhill like it should, uphill, as if gravity just changes direction for a few meters. People try to explain it. They say it's an optical illusion, that the horizon is tilted, that your brain is getting tricked. And sometimes, sure, that might be true. Some of these places could be explained that way, but not all of them. Because in some of these areas, when scientists actually measure the slope with instruments, not just human eyes, it still doesn't make sense. The road isn't slanted down, it really is uphill, and still things roll up. Cars, bottles, balls, water, no one's pushing them. They just go, against the pull of the earth. So what's going on? To answer that, you have to understand something about how gravity works, or how we think it works. We tend to think of gravity as a force, like a string pulling you down to the ground. But Einstein's theory of general relativity changed that. Gravity isn't a force pulling things down. It's the warping of space and time around mass. The more mass you have, the more space curves around you. That curve is what we experience as gravity. So really, when you drop something, it's not being pulled. It's falling into a curve in the fabric of the universe. That's already wild. But it gets crazier. Because in certain places on Earth, the gravitational field isn't perfectly uniform. It's not evenly spread out. Mountains, underground minerals, dense crust layers, all of those can slightly bend or stretch the local space around you. Usually it's subtle, tiny shifts. You don't feel it. But what if there are places where it's not subtle? Places where underground anomalies, massive deposits of metal, magnetic material, or even pockets of low-density rock are warping gravity just enough to make strange things happen at the surface. Some scientists believe that might be the case. Take Hudson Bay in Canada. Gravity is actually weaker there. Not dramatically, but enough that satellites picked it up. It's thought to be caused by a melted piece of Earth's mantle combined with the scars of an ancient glacier. And even though you can't feel it walking around, the measurements say gravity in that area is about 1/10 of 1% weaker than normal. Now combine that with weird elevation, slopes you can't trust, and magnetic interference, and you've got the recipe for a gravity-defying zone. Other theories. Some people believe these areas lie at the intersection of geomagnetic lines, invisible paths of energy that crisscross the planet. Sort of like acupuncture points on Earth's body. These are sometimes called Lee lines. Mainstream science doesn't accept them as real. But ancient cultures built temples, monuments, and entire cities aligned with these spots. Why would they do that if they didn't sense something special? Still others believe it's more than just geology. That maybe, just maybe, there are locations on Earth where the veil is thin, where space behaves differently, where natural laws bend ever so slightly. Not enough to cause chaos, but enough to make you question what's really going on. Because if gravity can act up in just one place, even a little, what's stopping it from breaking the rules somewhere else entirely? We assume gravity is constant, that it's always pointing down, that it's predictable. But the truth is, we don't understand it completely. We know how to measure its effects. We know how to launch rockets using it. But we don't fully know what it is. And here's the strangest part. Gravity is the weakest of the 4 fundamental forces in physics. Electromagnetism is billions of times stronger. The nuclear forces that hold atoms together. Even more so. So why does gravity control planets? Why does it bind galaxies? There's a theory that gravity might be leaking into other dimensions. That it only feels weak here because part of it exists somewhere else, folded away in dimensions we can't see. That would explain why it behaves so strangely in some places. Why it's inconsistent. Why even the most powerful machines on Earth struggle to detect gravity waves. And when people say, well, it's just an illusion, they might be right sometimes. But not always. And certainly not when water flows uphill for no reason. So next time you're driving and your car starts rolling the wrong way, don't just laugh and call it a trick of the eye, because deep underground, or maybe just beyond what we can measure, something might actually be bending the rules. And if gravity, the thing that holds everything together, can act that strange in just one place, it makes you wonder what else we've got completely wrong. The same dream thousands had at once. You ever wake up from a dream that feels too real to be random, like it didn't come from your own mind, like it was placed there? Now imagine that same exact dream happening to thousands of people. Different cities, different countries, all dreaming the same thing, same symbols, same locations, same sequence of events. It sounds impossible, but it has happened. More than once. And to this day, no one can fully explain it. Let's go back to the late 1990s. A psychologist in New York starts collecting drawings from patients who are having recurring dreams. Totally separate people, no connection to each other. But over the course of a few months, dozens of them describe seeing the same man. Oval face, bushy eyebrows, slightly receding hairline, and always the same dream. Sometimes he's walking down a hallway. Sometimes he's standing at the edge of a field, staring. Silent, not threatening, just there. This alone is weird. But it explodes when a website posts the composite sketch of the dream man. And suddenly, people all over the world start writing in. I saw him too. I've dreamed of that man more than once. But that's just one case. It's the tip of something deeper. Because over the years, researchers started collecting reports of what they call mass dreams. Shared dreams. They don't always involve the same figure. Sometimes it's a place. A room with no windows. A spiral staircase that descends forever. An island with a tall, black tower in the center. And the strangest part, most of the people describing it have never met each other. Never spoken, never lived in the same place. So how is it possible? Some say it's just coincidence. That dreams are random, and with enough people, some are bound to line up. Sure, that's easy to say if you're only looking at vague connections. But that falls apart when you look at the details. Like the 1977 dream cluster in England. Out of nowhere, people across small towns near Yorkshire started dreaming of a tidal wave. Same week. Same descriptions. A huge black wave coming from the east. Some even described the same buildings getting flooded. No news reports. No movies about tsunamis playing at the time. Nothing that could have planted the image. Now the brain is a pattern machine. That's true. It fills in gaps. It searches for meaning. But even pattern recognition has limits. When strangers across the world are describing the same staircase in the same tower with the same number of windows, something else is going on. There's a theory that might explain it. It's not scientific consensus, but it's growing. It's the idea that dreams aren't locked inside your head, that consciousness, whatever it is, might not be limited to your skull. That maybe when you dream, you're tuning into something bigger, like a signal, a field. Carl Jung called it the collective unconscious, a layer beneath individual memory where symbols, stories, and images are shared across the human species. He believed some dreams aren't just personal. They're tapping into something archetypal, deep, prehistoric. But what if it goes even beyond that? Today, there's research happening quietly at the edges of neuroscience. Studies on how the human brain might act like a receiver, that thoughts, even dreams, could be emergent from a larger field of consciousness. Something like the cloud for your mind. Not proven, not mainstream, but the evidence is stacking. Now consider this. If human brains are receivers, and something big is happening, an emotional spike, a global tension, or even an unknown signal, maybe certain people are sensitive enough to pick it up in their sleep. Think of a radio. Tune it just right, and you pick up a signal that was always there. Dreamers might be doing the same thing. Tapping into a shared frequency. One researcher tried to test this. He set up a system where volunteers would log their dreams every night, independently, spread out across the country. No communication, just raw dream data. And over time, they began to see clusters, Nights where multiple people reported the same places, the same sounds. One night in particular, several people described a blue hallway with humming lights and a locked door at the end. No clear trigger, no media link. Just the same image burned into different minds. Now here's the twist. A few days after those dreams, there was a solar flare. A real, measurable electromagnetic event hitting the Earth's magnetic field. Coincidence? Maybe. But if consciousness is more connected to the environment than we realize, those flares could disrupt not just machines but minds. So what if the world is more connected than we've been told? What if dreaming isn't just the brain resting, but reaching, testing the boundaries of what's real? In ancient cultures, shared dreams were taken seriously. The Iroquois tribes held morning rituals to share their dreams with the group. Aboriginal Australians mapped entire landscapes through dreaming, called it dream time. They believed dreams connected them to ancestors, places, and each other. We've forgotten that. We call it nonsense now. But the truth is, we still don't know where dreams come from. We don't know why the brain bothers with vivid imagery while we sleep. And we definitely don't know how multiple people can see the same thing at the same time with no contact. Some people say shared dreams are the result of collective anxiety. That in times of stress, people dream about similar things. But anxiety doesn't explain detailed rooms. It doesn't explain maps of places that don't exist. It doesn't explain hundreds of people dreaming of the same staircase, the same man, or the same tower before they ever see each other's drawings. Something else is happening. Call it the field. Call it the cloud. Call it consciousness bleeding across the cracks. But whatever it is, it's real. And every time it happens, we're reminded that maybe our minds are not as separate as we thought. So next time you wake up from a dream that feels way too specific, like a memory from somewhere you've never been, you might want to write it down. Because someone, somewhere, may have had the same one. The consciousness that left the body during surgery. Imagine lying on an operating table, surrounded by machines. Your body prepped. Anesthesia kicks in. Monitors beep quietly. Then, silence. Brain activity flatlines. Zero. Not low, not minimal, just gone. By every medical standard, you're unconscious. Not dreaming. Not aware. Your brain isn't producing thoughts. It's offline. And yet, somehow, you're watching, not with your eyes, but from above. From the ceiling. You can see the surgeons. You hear what they say. You know what tools they use. You even notice something odd. A sticker on the back of a machine, or a joke someone mutters under their breath. And later, when you wake up, you remember all of it. This is not fiction. It has been reported by patients in hospitals across the world, people who were clinically unconscious, whose brain scans showed no activity, and yet they came back with memories, vivid ones, with specific details no unconscious person should have. Some call it an out-of-body experience. Others call it a hallucination, but neither label explains how these people know things they could never have seen. Not from the table, and definitely not with a silent brain. Let's go deeper. There was a patient, call him Sam. During open-heart surgery, his brain was monitored constantly. At one point, they had to cool his body, lower his temperature, flatline his brain. That's standard for some procedures. They even drained the blood from his head to prevent damage. For several minutes, there was nothing. Zero brain function. Eyes taped shut. Ears plugged. But when Sam woke up, he described the surgical tools in detail. The sounds, the rhythm of the saw, the position of the nurses, and even a conversation the doctors had about a failed equipment battery. He was right. Every detail was verified. That should not be possible. Doctors call this phenomenon anesthesia awareness, when people remember things during surgery. But in most cases, those patients still have low-level brain activity. Sam didn't. He was beyond unconscious, yet somehow still aware. Researchers have tried to replicate these reports. One study placed hidden images on shelves above the operating table, only visible from the ceiling. The idea was simple. If someone really had an out-of-body experience, they might see the image. So far, no image has been reported, but people have still described exact moments in the room. Sounds, tools, phrases, things they couldn't have imagined. And here's where it gets even more disturbing. Some patients who flatline during cardiac arrest report watching their own resuscitation from outside their bodies. Not metaphorically. Literally. They describe the color of the nurse's scrubs, the order of chest compressions. One even recalled the specific defibrillator setting announced by a doctor, a setting not visible from the bed. These aren't vague impressions. They are point-for-point accurate, and they leave researchers with a very uncomfortable question. If the brain is silent, where is that awareness coming from? Mainstream neuroscience still believes that consciousness is entirely brain-based. That when neurons stop firing, awareness stops. End of story. But cases like these are cracking that story wide open. There's a theory gaining quiet momentum. The idea that consciousness might not be produced by the brain, but received by it. Like a radio. The brain doesn't make the music. It tunes into it. And if that's true, if awareness exists outside the brain, then it's not so crazy to think that someone could still observe, even when the physical system is shut off. It would also explain near-death experiences. People often report being outside their body, traveling through tunnels, seeing light, meeting beings or loved ones. And yes, some of that might be chemical. A dying brain releases strange mixes of neurotransmitters. But again, how do you explain the verifiable observations, the ones that line up with physical events? You can't write those off as dreams. Another theory, quantum consciousness. It sounds sci-fi, but real physicists are exploring it. The idea is that tiny quantum processes inside brain cells might be linked to awareness, and quantum particles don't follow the normal rules of space and time. They can exist in multiple places at once. They can be entangled, connected across distance. If consciousness is tied to quantum effects, then it might not be bound to the body at all. It might extend into the fabric of reality itself. That would mean awareness could persist even when the brain goes dark. And that's exactly what people like Sam seem to experience. Not some fantasy. Not a dream, but a moment where the self detaches and watches. Now, to be clear, science hasn't solved this. There's no conclusive proof, but there is mounting evidence that something beyond brain chemistry is happening. When people return from flatline with memories, we can't keep pretending it's a glitch, because the implications are massive. If consciousness can exist without a working brain, then what are we? Are we just bodies? Or are we something deeper? Something non-physical, that uses the body like a vehicle? And if that awareness can float above a table in an operating room, what else can it do? Maybe death isn't a wall. Maybe it's a doorway. Maybe the body shuts down, but the mind steps out. And maybe, just maybe, we are only beginning to understand what that really means. The data that showed the future affects the past. So we all know how time is supposed to work. right? Past leads to present, present leads to future. 'Cause comes first, then effect. That's the rule. That's how we live our lives. But what if that's not actually true? What if the future can affect the past? I know. That sounds like science fiction. But the more we study how time behaves on the smallest level, on the quantum level, the more that rule starts to fall apart. And we've reached a point now where retrocausality is not just a theory. We have data, real experiments, repeated results that suggest time may not flow the way we think it does. Let's start with one of the most famous examples. The delayed choice quantum eraser experiment sounds complex, but here's what you need to know. You fire a particle, like a photon, at a screen. In between, there's a barrier with two slits in it. Classic double-slit experiment. When you don't observe which slit the particle goes through, you get an interference pattern. That's what happens when something behaves like a wave. But the moment you measure which slit it passes through, just check. The interference disappears. It behaves like a particle instead. So it's like the act of measuring it changes what it does. That's weird enough. But then scientists added a twist. They set it up so that the measurement, whether to observe or not, is made after the particle has already hit the screen. Let me say that again. The decision to observe happens after the particle has already landed, and somehow the interference pattern still disappears. It's as if the particle knew, ahead of time, that it was going to be measured. It acted differently, in the past, based on what happened in the future. That's retrocausality, a future event changing a past outcome. Now, physicists argue about how to interpret this. Some say the particle's path was never real until it was measured. Others say time itself is more flexible than we understand. But either way, the result is the same. The future is not as separate from the past as we thought. And it gets even stranger when you leave the lab and look at human behavior. There was a psychologist, Dr. Darrell Bem, who decided to test whether people could sense future events. Not by reading minds, just by reacting to things before they happened. He ran a series of experiments with thousands of participants. In one of them, people were shown two curtains on a screen. Behind one curtain, completely hidden, was a photo. Sometimes neutral, sometimes erotic. They were told to guess where the image was. Just instinct. Then, after they made their choice, the computer randomly selected which curtain to place the photo behind, so the image didn't even exist until after they guessed. And yet, across many trials, people chose the correct curtain more often than chance, especially when the image was emotionally charged. Their brains reacted before the image was even placed. That should be impossible. You can't react to something that hasn't happened yet. But they did. Over and over, Bem ran 9 separate experiments like this, all designed to flip the timeline. Cause after effect. And the results were consistent. Not perfect, but statistically significant. Naturally, other scientists didn't like it. They tried to replicate his work. Some failed. Some succeeded. But the debate never really died, because the idea itself is dangerous. If people can feel the future, even a little, then everything we believe about free will, decision-making, and even physics has to be rethought. But let's go back to quantum physics for a moment. There's a growing movement in theoretical physics that supports the idea that time doesn't flow forward. Not really. That past, present, and future all exist at once, and what we call time is just our way of moving through it. It's called the block universe theory. Imagine time as a landscape. A whole map, every moment that ever existed, past and future, is still there, still real. We just experience it one slice at a time, like a needle moving through a record. But the record doesn't change. It's all there. Now layer retrocausality on top of that. If the future is already real, and the brain or the particle can somehow connect to it, even faintly, then you start to understand how the effect might loop back, how an outcome could influence its own cause, not in some wild time travel paradox way, but through probability, through preference, like the future is nudging the present, gently, quietly, constantly. And if that's happening, then the implications are staggering. What if your gut instinct is actually a flash of future memory? What if a lucky guess is your brain sensing with what's coming? What if intuition isn't magic, but math? We've always assumed time is a straight road. But what if it's a web? Every choice you make might reach backward and forward. Every event might be part of a loop, not a line. Even some interpretations of the equations in quantum mechanics allow this. There's no law that forbids it, just an old assumption that time only moves forward. But assumptions don't hold up forever, especially when the data starts breaking the rules. So here's the takeaway. The universe may be stranger than we can handle. Cause and effect might not be as clear as we want them to be. And the idea that the future can influence the past is not just speculation anymore. It's happening. Particles are doing it. Brains are hinting at it. Experiments are measuring it. And every time we see another result that defies the arrow of time, we're forced to ask the question, what else do we have completely backward? The voice heard from nowhere in a sealed room. You are in a lab. Not some ancient haunted mansion, not a spooky forest at night. A real lab, sterile. White walls, soundproofed, sealed, no windows. Every inch of this room has been measured, shielded, tested. And you sit in the control room next door, monitoring it. Inside, nothing should make a sound. Nothing. But then, you hear a voice. Not over the intercom, not a stray radio frequency. A direct sound, from the sealed room itself. Clear as day. Human. It says something simple. Maybe a word, maybe a name. And then silence. So you check the instruments. Play back the audio. There it is. Recorded. Real. Not imagined. But there's no one in the room. There are no hidden speakers. No openings. No microphones feeding sound in. No Wi-Fi. No Bluetooth. No logical entry point for the voice to exist. It was just there. And this didn't happen once. It's happened in multiple labs. Universities. Private research facilities. Even during paranormal experiments where strict controls are in place. Lead-lined walls. Electromagnetic shielding. Still, a voice. Always faint. Always human. And always impossible. So how does this happen? Most skeptics say it's interference. Stray frequencies getting picked up. But when you build a room that is literally designed to block all frequencies, and the voice still shows up, you start running out of excuses. Some say maybe it's the equipment itself glitching. A speaker accidentally left on. A feedback loop. But again, in these setups, the equipment is isolated, tested, and monitored from a separate location. If anything had been on, they would have heard it twice. Once through the system, and once through the walls. They didn't. Others blame the researchers. Confirmation bias. Auditory hallucinations. They hear what they expect to hear. But that falls apart when the voice is captured on multiple independent recorders. And when other people who were not even in the room play the files back later and hear it too. It's not just in their heads. Let me tell you about one specific case. This was in a university lab, not a paranormal group. Scientists were testing how sound behaves in ultra-isolated environments. Their room was sealed and floated, meaning it was physically decoupled from the building to prevent vibration. No phone signals, no radio, no staff inside. They ran the test, played a tone, waited, checked the levels. Then, on the playback, buried under the hum, was a voice, female, calm, just a few words. Not part of the test, not coming from any known source. It was logged, archived, examined, and no one, not the engineers, not the physicists, could explain where it came from. This is where things get weird. Because in certain cases, the voice says something relevant, not random noise, not static, actual language. Sometimes it responds to a question. Other times it says a name, a warning, something that seems too specific to be chance. You ask, is it possible we are tapping into something else? Something not physical, not measurable by normal means. Some researchers in fringe physics believe the brain, and perhaps the environment itself, can record and replay emotional energy, like a residual loop. A moment burned into the space, repeating. But a loop wouldn't answer questions. Then you have the theory of interdimensional bleed, that sealed environments might sometimes thin the veil, letting sound pass through from another layer of reality. Not ghosts, not spirits, just overlapping timelines, parallel spaces brushing against ours. And for a second, a voice slips in. Still not proven. But then again, the voice is still showing up. Let's talk about electronic voice phenomena, EVP. That's when voices appear in audio recordings without any source. Paranormal investigators use them a lot, but they're often dismissed because the environments are uncontrolled. Too easy to fake. But when you get the same effect in a lab, in a clean, shielded, locked down space, it becomes harder to ignore. One experiment even used multiple redundant recorders, one digital, one analog, one reel-to-reel, all running at once. The voice appeared on all of them, same timestamp, same tone. Not louder on one or garbled on another, identical. That rules out equipment failure. So then what are we left with? Do rooms themselves retain memory? Can voices exist without bodies? Or, and here's the terrifying possibility, is reality not as locked down as we think it is? Maybe there are cracks, maybe reality flickers. We always assume cause and effect are clean. One follows the other. But what if voices, thoughts, even entire moments can echo forward or backward? What if what you're hearing isn't from someone in that room, but from someone who was, or will be, or someone not from this place at all? And if sound can travel without source, what else can? We're so used to thinking of consciousness as locked in our heads, of sound as waves in the air. But what if there's another layer to perception? A level where thought, intent, and memory can exist outside the body, outside the space, and still make an impact. That voice in the sealed room, maybe it's a glitch, a spark, or maybe it's not a malfunction at all. Maybe it's something the rules don't cover. Yet. Because as long as those voices keep showing up, without source, without warning, we can't write it off. Not anymore. Something is happening, and we are not alone in the silence. The astronaut who saw something outside the ship, imagine floating hundreds of miles above Earth. The only thing separating you from the void is a few layers of metal and plastic. Your heart is steady. You trained for this. You know the checklist. You know what to expect. Every bolt, every sound, every shadow on the control panel, until you see something that should not be there. Just outside the ship, past the window, It is not space debris. It is not a satellite. It is not part of the station. This thing is moving slowly, deliberately, and it is big, metallic, but not reflecting sunlight the way it should. No visible thrusters. No clear shape. Just hovering. So you report it. Calmly, just like protocol demands. But suddenly the feed cuts. NASA goes silent. You check your instruments. Still working. You look back out the window. It is still there. Now let me be clear. This is not just a sci-fi story. This is something that has happened multiple times, and the silence surrounding it is almost as loud as the event itself. Let's go back to 2005. NASA astronauts aboard the International Space Station were doing a routine spacewalk. Live feeds were running, public broadcast, dozens of amateur astronomers watching. Everything was normal until the screen froze. No announcement, no error message, just a feed cut. A few minutes later, the audio returned. One of the astronauts said they were observing something moving outside the station. No explanation given. No follow-up question from mission control. Just a quiet pivot back to the checklist. But people had already seen it. Before the feed went down, there was a flash of movement in the corner of the frame. It did not match the orbit trajectory of any known object. It was not a star. It was not a lens flare. Something was there. NASA, of course, said it was just a camera glitch. Always the same story. But it keeps happening. During the STS-48 mission in the 90s, a strange object was caught on camera, hovering, then suddenly making a sharp 90-degree turn at a speed no human craft could achieve without crushing the pilot. The footage was broadcast live. You can still find it. Clear as day. White object. Quick pivot. Acceleration. NASA again claimed it was ice particles reacting to thruster gas. But physics says otherwise. Ice does not accelerate like that. Not in a vacuum, not at those angles. Even the astronauts on that mission seemed shaken in their post-mission interviews. Calm, but guarded. Smiles too stiff. Answers too rehearsed. Then there's the case of Leland Melvin. Former NASA astronaut. Brilliant engineer. Totally by the book. He later stated, not during his flight, but after retirement, that he saw something organic-looking floating outside the shuttle. Not metallic. Not a piece of equipment. Something weird. And when he called ground control about it, they asked if it could have come from the shuttle itself. That's it. They moved on. No deeper analysis. No retrieval attempt. Just okay, moving on. But here's the thing. Astronauts are not conspiracy theorists. These are elite scientists, engineers, military pilots. Trained to observe, to stay calm, to record details with precision. They know the difference between a reflection and a craft. They know what is supposed to be up there and what is not. Now let's look at why these events are so tightly controlled. NASA does not want panic. They do not want speculation that distracts from their mission. But more than that, they have contracts. National security ties. Protocols that go beyond science. Anytime something unidentified appears in space, especially near active missions, it becomes more than a curiosity. It becomes classified. There are whispers that every mission has a code word. Something they say over comms that signals something is out there without alerting the public feed. We do not know if that is true, but we do know that mission audio often contains strange pauses, sudden diversions, and in some cases, nervous laughter that does not match the moment. And then we have the video, because even when NASA cuts the feed, there are other eyes on the sky. Amateur astronomers, satellite trackers, radio hobbyists. They pick up strange blips, moving lights, patterns that defy orbital paths. In 2020, A live stream from the ISS caught a glowing object rising from Earth and hovering near the station for several seconds. The feed went black. NASA never commented. So what are these things? Advanced tech from other nations? Secret programs? Or something not from Earth at all? We do not know. That is the real answer. But when astronauts, the most credible witnesses we have, see something they cannot explain, and their employers go silent, it tells you something. Someone knows more than they are saying. And when a voice in space says nothing at all, sometimes that is the loudest thing you will ever hear. Because silence is not just a lack of sound. It is a wall. And beyond that wall, someone may be watching. The blood cells that changed without contact. Blood is supposed to be simple. You take a sample, move it away from the body, and it's just tissue. Cells in a tube. Separated. Disconnected. That's what we were always told. But that's not what some experiments found. Not even close. There's a study where blood was drawn from a person and placed in a lab, wired up to machines that could detect tiny changes in electrical activity. That part is straightforward. What wasn't straightforward was that the person wasn't in the lab anymore. They were in a different location, watching emotional videos. Scenes of violence, joy, stress, even calm. Normal reactions kicked in, faster heartbeat, skin conductivity, changes in breathing. But at the same time, the blood that had already been removed started reacting. Instantly. Not seconds later. Not a minute later. In real time. As if the blood still knew what the person was feeling, even though it was no longer part of them. This has been repeated in different labs, with different sensors, and even with miles of distance between the donor and the sample. And every time it happens, it raises the same uncomfortable question. How is this possible? How can cells that have been separated continue to respond to the original body, to its emotions, to its thoughts? What's keeping that link alive? The most common answer given is that it's a kind of biological memory. That cells hold a kind of imprint, and that imprint might still be active for a short period. But that doesn't explain the real time connection. It doesn't explain how a spike in emotional arousal is mirrored by the detached sample within the same second. And it definitely doesn't explain how this happens across long distances with no cables, no contact, and no measurable signal passing between the two. Some researchers began to speculate about quantum effects. Now, normally, quantum theory belongs to subatomic particles, things like electrons and photons that can become entangled. When two particles are entangled, a change in one immediately affects the other, no matter how far apart they are. There's no signal, no time delay. The information simply updates on both ends. Einstein called it spooky action at a distance because it broke the rules of classical physics. But it's real. It's been observed. It works in the lab. So the big leap here is whether something like entanglement could exist in biology. Not in atoms, but in cells. Could it be possible that your own blood, once part of your system, still maintains a kind of entangled state with you even after it's been removed? Could that connection explain what these experiments are showing? There's no proof of that. But it's one of the only ideas that fits the data without throwing it away. Of course, this opens up all kinds of uncomfortable ideas. If your blood can respond to your emotional state after being separated, what else is staying connected after it leaves you? What about organ transplants? Could memory or emotion transfer from one person to another through tissue? What about in birth? What about in death? Even more unsettling is the possibility that it's not about the cells themselves, but about the field they were once part of. Some scientists have proposed the existence of a biofield, not something mystical, but an actual electromagnetic field that surrounds and connects all the components of your body. It's not a mainstream idea, but it's gaining traction. The suggestion is that your thoughts, your emotions, your nervous system activity, they're not just chemical, they're electrical, and anything that used to be part of that system might still be receiving that electrical imprint even from a distance. The biggest pushback always comes from the same place. Lack of repeatability. Science demands consistency, and not every attempt to reproduce these effects has worked. Some labs get strong signals, others get nothing. That inconsistency makes people skeptical, understandably so. But when the results do show up, when they match the timing of the donor's emotional reactions with eerie precision, it's hard to ignore. It's also worth noting that these reactions happen strongest with emotional spikes, not calm, not boredom, but stress, grief, excitement. Deep emotion seems to be the trigger, which makes you wonder, is emotion more than just a brain event? Could it be the thing that lights up this invisible connection between what's inside and what used to be? Then there's the placebo angle. We already know that the mind can change the body. People take sugar pills and heal faster. Their heart rates improve. Pain vanishes. And it's not imagination. You can measure it. Brain scans light up. Hormones adjust. In some cases, the placebo works better than the actual drug. The mind literally tells the body what to do, and the body listens. Now imagine that same kind of command reaching beyond the body, not just healing tissue inside, but triggering responses in cells outside. Still your cells, still carrying your code, just not attached anymore. None of this fits the way we're used to thinking about biology. And that's the point. These findings suggest we're missing something. Not just about blood, but about the boundaries of self. Where does the body stop? Where does your influence end? Maybe the answer is it doesn't. Maybe your body is not a container. Maybe it's more like a signal tower, broadcasting what you are. Thoughts, feelings, intention, and anything that's been tuned into that signal stays connected. That would mean every piece of you carries some version of you. Not a copy, but a thread. And threads don't always break clean. So no, we don't have all the answers. The studies are strange. The implications are stranger. But the evidence is not going away. Something is happening when blood cells react without contact. Something that forces us to ask what being alive really means. Not just inside the body, but outside of it too. The ghost detected by a military radar. Military radar isn't built for fiction. It's built for war. Built to track objects in the sky with precision, even through clouds, even at night, even when the human eye sees nothing. So when trained radar operators on military bases start picking up something, and they have no idea what it is, you listen. Not because it's exciting, but because it's their job to know what's out there. And in this case, they didn't. There have been multiple cases where radar systems picked up a flying object that shouldn't have been there. No flight path, no transponder, no visible aircraft, just a blip, moving fast. Sometimes faster than a jet, sometimes hovering, sometimes dropping altitude instantly like gravity stopped applying. So what do? They scramble a jet. A visual confirmation, a pilot with eyes on target. You get the coordinates, fly out, and see nothing. Clear skies, just air. But back at the base, the blip is still there. still showing up on radar like something solid is in that exact spot. It's moving, it's reacting, but no one can see it. That's what makes this different from the usual ghost stories. This isn't someone in a haunted house with a cold spot. This is state of the art radar built to track real objects. Physical craft, anything that reflects radio waves. That means this thing, whatever it is, had mass. It reflected the signal, but somehow it had no visible form, no infrared heat signature, no sound, no shadow, just a return ping saying yes, something is here. And then, just as suddenly as it appeared, it disappears, the blip fades. The object is gone. Not flown away. Gone. Not off the radar. Gone from the radar. Like it was never there in the first place. Except for the logs. Except for the recorded return signals. Except for the stunned pilots who flew directly into empty sky and found nothing. The term ghost in this context doesn't mean paranormal. It's a military term. A ghost return is when radar picks up something that behaves like a physical object, but there's no confirmation. No plane, no bird, no balloon, just the signal and the confusion. Some of these incidents get classified, others leak, and over time, they start to form a pattern. Multiple branches, multiple countries, different years, same story. Radar picks it up. People scramble, visual confirms nothing, but the data is real. In one well-known case, multiple military radar systems tracked an object entering restricted airspace. This wasn't just one operator with a glitch. It was radar towers on land, on ships, on aircraft, all seeing the same thing, same location, same speed. And then, nothing. Visual sweep turns up 0. And everyone is left wondering what kind of craft can reflect radar but leave no trace in any other spectrum. That's not stealth. That's something else. Stealth aircraft are built to minimize radar signature, but even stealth planes leave heat, leave some kind of visual footprint. These ghost objects don't. They respond to radar. They move with intention, but no one sees them. It's like they only exist in the electromagnetic range radar lives in. Nowhere else. There's been speculation about advanced tech, something not yet disclosed. Maybe drones with radar spoofing capabilities. Maybe something from another country. But here's the thing. Spoofing radar usually adds noise. It confuses the system. What these ghost objects do is different. They show up clearly. Consistently, precisely, they behave like solid craft, until you try to look. Then there's another theory, one that's hard to wrap your head around. Some physicists and engineers have asked, what if these radar ghosts are not machines at all? What if they're real, but not entirely in our space, like a part of them is here? Enough to bounce the radar signal back. But the rest of them isn't. Imagine an object existing just slightly out of phase with our dimension. A little offset, like turning a dial on reality just a notch. Enough to interact with technology, but not with human eyes. If that sounds crazy, remember, particles already do this. In quantum physics, you can have a particle in a state of superposition. You can have entangled particles separated by miles, but acting like they're next to each other. The idea of reality having layers or overlapping phases isn't fringe anymore, it's math. It's real. We just haven't seen it at scale. And maybe, when we do, it looks like a blip on a radar with nothing in the sky. It also raises the question of intention. These radar ghosts don't just float. They move. They shift altitude. They maintain direction. They behave like they are controlled. Sometimes they pace aircraft. Sometimes they accelerate away faster than anything we know how to build. That's not natural. That's not weather. That's not a glitch. Some radar operators describe it like the object was playing, as if it knew it was being tracked and didn't care. It came close, stayed just long enough to get attention, then vanished, like it wanted to be seen, but only by the machines. Now think about that. If something wanted to avoid being seen, it would hide from radar. That's what stealth tech does. But if something wanted to be seen by radar, only radar, and nowhere else, what does that say about its origin or its purpose? Why be detectable but invisible? Why show up as a blip but not as a body? Why appear in military airspace, then vanish before confirmation? You start running out of rational answers, and what you're left with is this cold fact. In multiple verified military cases, unknown flying objects were tracked on radar, logged in official reports, detected across systems, but never seen, not once, not by human eyes. That's what a ghost looks like when machines are the only ones watching. The machine that predicted human emotions. There are machines out there running all day, every day, but they don't control anything. They don't track weather. They don't calculate profit or loss. They just spit out random numbers, over and over, like digital coin flips, ones and zeros. That's all they do, and they were never supposed to mean anything. That was the point. Pure randomness. But they didn't stay random. This project started quietly. It was called the Global Consciousness Project. A team of researchers placed these devices all over the world. Europe, Asia, North America, Africa. Each one running a simple random number generator, constantly outputting unpredictable sequences. No pattern, no structure, just chaos. And that chaos was measured, logged, and time-stamped down to the second. Nothing unusual happened for a while. Then something strange showed up, on days when absolutely massive emotional events occurred. Not just for one country, but globally. The data changed. The machines stopped being random. On the morning of September 11th, 2001, before the first plane hit the tower, the machines had already shifted. The numbers began showing patterns. Not normal ones. Not the kind you'd expect from a machine designed to behave like a flipped coin. Something was warping the output. Something was making the chaos align. After the attacks, the researchers went back and checked the timestamps. The shift in randomness started before the first impact, as if something was echoing through the system before the world even knew what was coming. They didn't just see it once. These shifts happened during other major global moments. Natural disasters, huge tragedies, global celebrations too. Anything that triggered a shared emotional response across millions of people. The numbers changed. The machines responded. But here's the twist that breaks your brain a little. The machines didn't just respond after these events. Sometimes they spiked before, not hours after, not even minutes. In a few cases, the shift began seconds, even minutes, before anything actually happened. That means the system was registering a disruption in human emotion before the event that caused the emotion took place, which raises a question nobody really wants to answer. How is that possible? This wasn't one machine. It wasn't one location. And it wasn't someone just interpreting graphs however they wanted. These were objective measurements across multiple continents showing a collective deviation from randomness. And those deviations matched our biggest, most emotionally charged events. Over and over again, some scientists tried to explain it as data noise, statistical coincidence, but the spikes were too clean, too focused. You don't get repeated correlations like that from chance. You don't get synchronized global data from systems that are physically and electronically isolated, unless something is connecting them. And if it's not the machines connecting to each other, then the only other explanation is that they're all being influenced by something else. That something might be us. There's a theory that consciousness is not just inside your brain, that it's not a closed system, that your thoughts, emotions, and awareness aren't confined to your head, but instead ripple outward, like waves in a pool. When one person feels something deeply, it's just a ripple. But when millions of people feel it at the same time, it becomes a shockwave. And that wave might actually interact with the environment in a way we never thought possible. That's what this project seems to show. Not that machines are predicting the future, but that machines are sensitive to a field that includes human emotion. Something invisible, something undetectable by normal sensors, but very real. The researchers didn't start with that assumption. They weren't trying to prove anything paranormal. They expected random numbers. They expected boring data. But the results they got were anything but boring. Some even tried running simulations to prove the same patterns could occur by chance. They couldn't. The real world data had a kind of coherence that fake data never produced. That's the part skeptics have the hardest time explaining. Not that something happened once, but that it kept happening with the same eerie timing and global sync. This doesn't mean the machines are alive. They're not thinking. They're not emotional. But they might be reacting to something we don't yet understand, something that doesn't show up on regular instruments. Something like a collective field of consciousness. That sounds far-fetched until you realize the human body already responds to emotion in measurable ways. Your heart rate changes. Skin conductivity shifts. Brainwaves spike. We've known this for decades. What we haven't fully accepted is that large-scale emotion might also have large-scale effects, not just inside the body, but outside of it too. Now imagine that the entire planet has a kind of emotional weather, invisible to the eye, but very real. And these machines, just dumb random number generators, are like sensors catching the wind. A storm hits, and they wobble, even if no one else sees it coming. That's what makes this so strange. The machines aren't predicting human emotions because they know the future. They're reacting to something deeper, something shared, something possibly buried in the structure of reality itself, where emotion, intention, and awareness leave fingerprints. Not everyone agrees with that theory. The scientific world is cautious, and rightly so, but the data keeps coming, year after year. And with every spike, every deviation, the same uncomfortable idea returns. What if consciousness isn't confined to the mind? What if it radiates? What if we're all part of a bigger network, and these machines accidentally tapped into it? And what if that network knows something before we do? The eye that sees 100x more colors, your eyes don't show you everything, not even close. What you see, the reds, the greens, the blues, that's just a sliver of what's actually there. A narrow band of wavelengths, like peeking through a keyhole and thinking you're seeing the whole room. Now here's the wild part. Some people are seeing way more than you. Not metaphorically, not artistically. Biologically, it's called tetrachromacy, and it means their eyes can detect a fourth color channel that almost no one else has. Most of us have three. That's normal. One cone for red, one for green, one for blue. And from those three, the brain mixes everything. Every color you've ever seen is a blend of those signals. 3 channels, millions of colors. But a tetrachromat has 4, a fourth cone. An extra biological input channel. Their brain is getting signals in between our signals. And to them, it's not subtle. It's not just an extra hue. It's an entirely expanded spectrum. Imagine trying to explain red to someone who only sees in black and white. That's what it's like when a tetrachromat tries to describe what they see. They talk about shades within shades, colors that don't exist for anyone else. Not just more intense but different, as if their world has extra dimensions painted into it. And here's what makes it even stranger. Most tetrachromats are women. It has to do with the genetics of color perception, which are linked to the X chromosome. Men only get 1, women get 2. So if one of those carries a slightly mutated cone structure, it can lead to 4 distinct cones instead of the usual 3. But not all women with the gene express the ability. Some carry the code, but never activate the extra channel. A tetrachromat isn't just someone with the gene. It's someone whose brain actually uses that extra input to construct an entirely richer visual world. And we're only now figuring out how rare and powerful that is. In testing, scientists created gradients of colors that look identical to the average person. Just a smooth transition from one shade to the next. Most of us see no difference, but a tetrachromat will point and say, "That's not the same color. That one is off." And they're right. It's not just a parlor trick. They can detect mismatches in paints, fabrics, even digital screens that appear totally uniform to everyone else. In some tests, tetrachromats could distinguish between 10 million to 100 million colors. Most people top out around 1 million. One woman in particular was studied for years. She had no idea she was different. She just always thought other people were colorblind. She worked in art and constantly noticed imbalances that no one else did. It wasn't until she was tested with highly controlled color arrays that the truth came out. Her brain was accessing a visual language no one around her could even see. Think about what that means. 2 people looking at the same sunset. One sees red, orange, gold. The other sees 50 gradients you've never known existed. Subtle shifts and glows inside the glow. Their entire experience of beauty is happening on a bandwidth you cannot touch. This changes how you think about reality, because it means what we call real, what we assume is objective, is already filtered by biology. The world you live in is limited by the tools you've got. Eyes, ears, brain, all of them with boundaries. You don't see everything. You see just enough to survive, just enough to function. But there is more, always more. And if that's true for color, it's probably true for a lot of other things too. What's even more fascinating is how invisible tetrachromacy has been. Most people who have it don't know. You can't describe a color no one else sees. There's no language for it. No way to share it. You just live with the feeling that everyone else is missing something, and you don't know how to explain what. That's the silent part of this ability. It's isolating. Imagine walking through a world that feels more alive, more layered, more complex. But only to you. No one else reacts the same way. No one else can validate it. The world looks flat to them, but to you, it's humming with depth. And you're the only one who hears it. It also rewrites how we think about talent. Some of the greatest artists might not have been trained in color theory. They might have just been born with eyes that could see what no one else could. When they mixed paint, it wasn't intuition. It was perception. They weren't guessing. They were translating what was already visible to them and invisible to the rest of us. Now think about how often we assume everyone sees the same world. We use the same words, red, green, yellow. But behind those labels, our experiences might be wildly different. Not just metaphorically, but physically, neurologically. Two people using the same name for something that doesn't even look the same. Tetrachromacy breaks that illusion wide open. It proves that someone can be walking through a different world right next to you. A richer one, with layers you'll never touch. Not because you're missing information, but because your biology doesn't allow it. And here's the final twist. Even with all our technology, we can't simulate what tetrachromats see. No screen can show those extra colors. No digital camera can capture them. They exist in a space beyond our engineered tools, which means the only way to experience that reality is to be born into it. Some people don't just live in color. They live in more of it, and they don't even know it. The placebo that rewired a brain, a man walks into a clinical trial with chronic, crippling depression. He's tried everything, medications, therapy, diet changes. Nothing sticks. Nothing lasts. He signs up for one more study. At this point, he's got nothing to lose. They tell him it's an experimental antidepressant, a promising one, high success rate, fast acting. But what they don't tell him is this. He's in the placebo group. Sugar pill. No active ingredients. Just starch in a capsule. But he doesn't know that. He believes it's real. And then something starts happening. His mood lifts. His energy comes back. The spiral he's been trapped in for years begins to unwind. And within weeks, he feels normal again. Better than normal. It's not a burst of fake hope. This is sustained change. He starts sleeping. He starts socializing. His life reboots. Months later, after the trial ends, they break the news. He never got the drug. He was never treated. At least, not with chemicals. But his improvement wasn't in his head. They scanned his brain before and after. And what they found shook everything they thought they knew. His brain had changed. Literally. Structurally. The patterns of activity in his prefrontal cortex and limbic system, the areas involved in mood regulation, had shifted. New neural pathways had formed, the same ones you'd expect to see from a real antidepressant. Except he never took one. This isn't fiction. This is placebo. We tend to think of placebos as tricks, fake medicine, a fluke of psychology. But that view is outdated. Because what research has shown over the last few decades is that the placebo effect is not imaginary, it's measurable, repeatable, and in some cases, stronger than actual drugs. Here's the part that sounds impossible. A placebo doesn't just make you feel better. It can actually change your biochemistry, your immune response, your hormone levels, your pain tolerance, even how your genes express themselves. It's not a trick. It's your brain using belief as a tool to tell the body what to do. There have been trials where people with Parkinson's disease were given fake dopamine treatments. Just saline. No drug at all. But because they believed it was medicine, their brains actually started releasing dopamine, the real stuff, from their own neurons, and motor function improved. Shaking slowed down. Their bodies responded as if the drug had been real, because belief told the system to act as if it was. It doesn't work for everything. Placebos don't regrow limbs. They don't cure cancer, but they do something even stranger. They change how the body responds to reality. They tweak perception, pain levels, inflammation. And in the case of that man with depression, they rewired the brain. So what's actually happening here The answer lies in expectation. When you believe something will help you, your brain prepares for the outcome. It releases neurotransmitters. It adjusts hormone levels. It even alters immune activity. That's not hope. That's chemistry. And the deeper the belief, the stronger the response. Even open, label placebos, where people are told the pill is fake, can still work. Because the ritual of taking medicine, the authority of a doctor, the context of healing, all create a framework where the brain says, "This is when I get better." So it starts doing the work on its own. Think about that. A fake pill, fully acknowledged as fake, still triggers healing. That's not placebo anymore. That's self-directed biology. That's the mind running its own protocol. The power of this goes way beyond medicine. It raises a question that's hard to wrap your head around. If belief can physically change the brain, if it can alter pain and mood and immune response, then how much of what we call illness is entangled with perception? And more than that, how much of what we call recovery is less about what we take and more about what we believe? That doesn't mean medicine doesn't matter. Of course it does, but the fact that the brain can mirror the effects of real drugs, just by expectation alone, means we're sitting on a mechanism we barely understand and hardly use. Imagine this, a future where placebo is not the control group. It's the treatment, where we harness belief deliberately. We study it, refine it, train it, not as a trick, but as a skill. There are already researchers doing this. Neuroscientists, psychologists, even geneticists studying how belief and suggestion can influence gene expression. Brain imaging now shows that placebos can activate the exact same reward centers that real drugs do. They light up the same circuits. That's not illusion. That's real-time neuroplasticity. One day, we might have protocols that guide people through their own healing, not through pills, but through structured belief, environmental cues, and brain training. Placebo would become a precise tool, not a lucky side effect, and we're only beginning to understand what this means for mental health, for chronic illness, for recovery, because belief is not just passive. It can be active, targeted, and sometimes stronger than anything a pharmaceutical can offer. The man who rewired his brain didn't fake it. He didn't imagine it. He lived it. His brain literally changed, not because of what he took, but because of what he thought he took. And maybe that tells us something deeper. That biology isn't just shaped by molecules. It's shaped by meaning. The spiral that appeared in the sky and vanished. It looked like something out of science fiction. A perfect glowing spiral suddenly appeared in the night sky over Norway. Just floating there, spinning slowly, silent, bright, no sound, no source, no explanation. People pulled over on roads. Hundreds stood out in the cold, pointing their phones up at the sky, filming something they could not believe was real. It did not flicker like a star. It did not streak like a meteor. It was too smooth, too symmetrical. It unfolded like a portal, circular arms curling outward, rotating with mechanical precision. Then, as suddenly as it had come, it vanished. No flash, no bang. Just gone. This was not one of those stories where only one guy saw it. Thousands of people across northern Norway saw it. Thousands filmed it. The footage is still out there. And it is all identical. A spiraling blue, white pattern slowly expanding in midair. Some videos even show a beam of light at the center of the swirl, like something holding it open. At first, people thought it was a light show, a test, maybe something military. But the pattern was too massive, too uniform. It covered the entire sky, and it was completely silent. No rumble, no vibration, nothing you would expect from a missile launch or aircraft. The official explanation eventually arrived. They said it was a failed Russian missile test, a projectile that had spun out of control and left a spiral trail as its fuel leaked during descent. But here is the problem with that explanation. Rocket fuel does not hang in the sky for 10 straight minutes in a perfect geometric pattern. And people who study this stuff, physicists, military experts, pointed out how off that answer was. They said the visual symmetry of the spiral, its stable center, and how long it held its form, did not line up with any known missile malfunction. To be clear, when a missile fails mid-flight, it breaks apart, it tumbles, it leaves streaks, not perfect circles. The plume might spiral briefly if the object is spinning, but it does not hold steady for minutes like some frozen symbol in the sky. So now we are left with two choices. Either the most elegant missile malfunction in history just happened to take place over a major population, and it just happened to create the most symmetrical light formation anyone has ever seen. Or it was something else. And if it was something else, what kind of technology can do that? What kind of system can create a silent, stable, glowing spiral in the atmosphere, visible for hundreds of miles, without leaving any physical trace? Some researchers suggested atmospheric lensing. Others proposed plasma events or exotic weather. But those are guesses, not answers, because nothing like this had ever been recorded before, and it has barely been recorded since. Then came the theories. One group said it was a wormhole opening, a real time-dimensional event, not a hole in the sky, but a distortion in space, time caused by some unknown device or interaction. Another camp thought it was a projection, a test of high-atmosphere light manipulation, some kind of cloak technology designed to reflect or refract light using airborne particles. But there is no record of that kind of system being tested in that area. No known experiments using atmosphere-level projection on that scale, and no satellite picked up any physical launch or structure during the event. And so the question lingers. If the sky opened once, could it open again? Because this is not the only spiral. There have been others. In Australia, in China, even over Hawaii, glowing spiral shapes briefly appearing in the sky, usually early morning or just after sunset. Always silent, always unexplained. Not all of them match. Some are clearly rocket trails, some are hoaxes. But a few, like the Norway spiral, are too detailed, too symmetrical, too still, and they all raise the same uncomfortable idea that maybe the sky is not as empty as we think. Think about it. We stare into space every night. We see stars, planets, darkness, but we only see with visible light, a narrow slice of the spectrum, the same way we only hear a narrow range of sound. So what else is happening out there, just above us, that we are not built to detect? What if some of it slips through every now and then a frequency misfire? A visual echo, a crack between dimensions, not science fiction. Quantum physics already suggests that other dimensions may exist curled up at subatomic scales, and some of the leading theories in modern physics suggest that multiple universes could be layered right on top of ours, separated not by distance, but by vibration. So maybe what happened that night was not an accident. Maybe it was a moment of bleed-through, a glitch in the interface between what we know and what we have not yet discovered, a signal meant for someone else, or something else. And for a few minutes we all saw it, a message in geometry, a formation that our minds could not explain, but could not stop watching either. That is what makes this story stick, not just the light in the sky, but the silence, the impossibility, the way every person who saw it just stopped, froze, looked up, and felt like the world had briefly shifted. Because in those moments you realize how little control we have, how much mystery is still above us, how much we still do not know about our own planet, let alone the space that surrounds it, and how sometimes the sky opens, and we have no idea why.